without using a calculator or mathematical tables, evaluate. So this is a question on fractions, and you're supposed to solve this on using this order, BODMAS. This is what you're going to follow, the order of operation. So we're going to start with the numerator. So for the numerator, we have half of 3.5 plus 1 and 1 over 2 into brackets 2.5 subtract 2 over 3. So we're going to follow this order, and according to this order, we should start with the bracket, solve whatever is in the brackets. And when I look at this one, whatever is in the bracket is 2.5, and 2.5 you can simplify it to 5 divided by 2 subtract 2/3. That is whatever is in the brackets here. That is what's supposed to begin with. So when you subtract these, you are supposed to get 11 over 6. 11 divided by 6. So now let's write this. The numerator is now simplified. That is a half of 3.5. You can write that one as an improper fraction, and that will be 7 divided by 2 plus 1.5. You can write that one as an improper fraction as well, and that one will be 3 divided by 2. Then once you work out whatever is in the bracket, of course this will be multiply by 11 over 6. That is what you got after working out whatever is in the bracket. That is 11 divided by 6. The next one now that should follow, we have off, and we have addition and multiplication. Off should come first, so work out that. So now we have a half of 7 over 2. This is simply multiplication, and this will be 7 divided by 4. So half of 7 over 2, that will be 7 divided by 4 plus 3 over 2 times 11 over 6. We're still reducing these. So from there we have addition and we have multiplication. So we start with multiplication. So we have 3 over 2 times 11 over 6, and these will be 11 over 2, because this will be by 3, 1 by 3, 2. So this will be 11 over 4. So we're still reducing it. So now we have 7 over 4 plus 11 over 4, and this will give 18 divided by 4. When you simplify these, it will give 9 divided by 2. So that is the numerator. Now let's go to the denominator. So for the denominator, we do the same thing. We have 3/4. So 3/4 of 2.5. We can write that one as a 5 over 2 divided by 1 over 2, like that. So according to these off and division, which one should come first? Off should come first. So you work out this one first. So 3/4 of 5 over 2. This will give 15 divided by 8. Now we can substitute. This will be 3 over 4 or 5 over 2. That is 15 over 8 divided by a half. And this will simplify to 15 over 8 times 2 over 1. And this one will give by 2, 1 by 2, 4. This will give 15 divided by 4. Now you have the numerator and you have the denominator. Now let us get the answer. So the answer we got in the numerator, that is 9 over 2. So we're now getting the answer, 9 divided by 2. Then divided by the denominator, which is 15 divided by 4. When you work out these, you get 9 over 2 divided by 15 divided by 4. This will give 9 over 2 times 4 over 15, like that. And this will give by 2, 1 by 2, 2. This will give, and then by 3, 3 by 3, 5. This will give 6 divided by 5. And 6 divided by 5 is equivalent to 1 and 1 over 5 as the solution. Simplify completely. 3x squared y squared plus 8xy, subtract 11, everything divided by x cubed, y cubed minus xy. So we're going to begin with the numerator. So for the numerator, so 3xy, x squared y squared plus 8xy, subtract 11. So a careful look at this, you notice that this is a quadratic expression. If you simply compare this with a standard quadratic expression, ax squared plus bx plus c, you notice it is forming a quadratic expression. So we need to factorize this. So to factorize this, let me look for two numbers. I'll use a factorization method. Look for two numbers whose product is 3 times negative 11, negative 33, and sum will be 8. These numbers are negative 3 and 11. So let us factorize. So we have 3x squared, y squared. Then 8xy, you can write it as negative 3xy plus 11xy, subtract 11. So let us factorize these. 3x squared y squared minus 3xy. Between these two, what is common? 3xy is common. So you have, you remain with xy, subtract, that would be 1. And then between 11xy and negative 11, you notice plus 11 is common. So you have xy, subtract 1. After doing that, so this one will simplify to 3x. Now moving from here. So you're moving from here. So this will give 3xy plus 11 into brackets xy minus 1. So that is what you get for the numerator. Then for the denominator, so for the denominator, we have x cubed, y cubed minus xy. So what is common between those two? Xy is common. Xy is common. You factor out and you remain with x squared, y squared, subtract 1. Then there's something that you notice about these. X squared, y squared minus 1. You can factorize that one further. That is the difference of two squares. So that you get, this is the same as xy subtract 1 multiply by x squared plus 1. That is a difference of two squares when you factorize. So therefore, you have now the numerator and the denominator. Now let's get the answer. The answer for the numerator, we got this is a 3xy plus 11 into brackets xy minus 1, everything divided by the denominator xy subtract 1 xy plus 1. So from there you notice this one will divide out and you remain with 3xy plus 11 in the numerator, then everything divided by xy into brackets xy plus 1. So that is the final solution. State all the integral values of x which satisfy the inequality. So to solve this question, you are supposed to extract two inequalities from this combined inequality, and this is how you're going to do it. So start by extracting that, and then the next one that you're going to extract is this one. So those are the two you're going to extract. So let's go to the first one. So the first one will be that you're going to extract will be 3x plus 2 divided by 4. less than or equal to 2x plus 3 divided by 5. We solve this one first, and we're going to cross multiply. Just treat this less than or equal sign as equals the same way we saw for x in an equation. So cross multiply, and you'll have 5 multiplied by 3x plus 2 is equals to 2x plus 3, like that. Opening the brackets, you get 15x plus 10 plus 10. So I will substitute this equal sign here. Let me just carry forward this inequality sign. There it is, less than or equal to. This will be 8x plus 12. Collect the like terms together. Take 8x to the left hand side, and you'll have 15x subtract 8x, that will give 7x, less than or equal to. Take positive 10 to the right hand side, and you get 12 minus, this will be 10, 12 minus 10, and this one will give you 2. So x will be less than or equal to 2 over 7. So that is the first one that you get. So we go to the other one. Let's go to the other inequality. So the other one is 2x plus 3 divided by 5 less than or equal to 4x plus 15 divided by 6. Again, you cross multiply, so you have 6 multiplied by 2x plus 3 less than or equal to 5 multiplied by 4x plus 15, like that. So this will give 12x, open the brackets, plus 18 less than or equal to 20x plus 75. So that is what you get. Then from there, like terms together, 20x, take it to the left hand side, you get 12x minus 20x, that will give negative 8x less than or equal to. Take positive 18 to the right hand side, so get 75 minus 18, that will give 57. And dividing both sides by negative, x will be, the moment you divide both sides by negative, note this please, this inequality sign will change to the opposite, so it is less than or equal to, so it becomes greater than or equal to. This is negative 57 over 8, and this one will be x is greater than or equal to negative 7, and this will be negative 7 and 1 over 8, that is 57 over 8. Now you have these two that you've obtained. You have the two. The question is state all the integral values of x that satisfy the inequality. So this is what you're going to do. You can draw a number line that will assist you to work out these. So let me draw a number line. Number line will assist you in getting these values. So you can see most of them are falling to the negative side. So we have 0, we have 1. This is 1, then we have negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8. So let me identify negative 7 and 1 over 8. Negative 7 and 1 over 8 will fall somewhere here. So it will be here. So this is a negative 7. And because it is greater than or equal to, you're going to have that one shaded, and then we shade everything that is to the, all these values are to the right, are satisfying that, like that. And then the other one is x is less than 2 over 7. 2 over 7 will be somewhere here, just between 0 and 1. And less than or equal to, again, as is you shade to the left, less than or equal to. So this is 2 over 7. And then this one is 7 and 1 over 8. So for this one, you shade to the left. So now look at the 2 points, all these values that are at the center here, between negative 7 and 1 over 8 and 2 over 7. Remember, the integral values, we are supposed to consider only the whole numbers only, no decimals, no fractions. So therefore, the first one, we begin from negative 7. So the integral values, negative 7, it could be -6, -5, -4, -3, -2, then -1, and finally 0, because you can't take 2/7 and -7 and 1/8. So that is how you're supposed to solve that question. Use the exchange rates below to answer this question. There's a currency, $1 US, and then they're buying and selling. Abwanja, a tourist arriving in Kenya from Britain, had 9,600 UK sterling pounds. He converted the pounds to Kenya shillings at a commission of 5%. While in Kenya, he spent 3/4 of this money. He changed the balance to US dollars after his stay. If he was not charged any commission for this last transaction, calculate to the nearest US dollars the amount he received. So we're going to begin by converting this amount, that is 9,600 UK sterling pounds, to Kenyan shillings. That is the first thing we're going to do. And which column are we going to use to do that? Look at 1 UK pound, buying and selling, buys at 164 and 3 cents, sells at 176.78. So every time you're converting foreign money to Kenyan money, you're going to use the buy. So you're going to use this buy, that is 164.33. So therefore, 1 UK pound buys at Kenyan shillings 164 and 3 cents. So what about 9,600 UK pounds? So this one you're going to multiply 164 and 3 cents, and this one will give, when you multiply these, you will get this one as 1,577 and 568 Kenyan shillings. So that is what you're going to get. That is what you're going to get. So after getting that, the next statement, this person did not receive the whole of this money. There was a commission of 5% during this conversion, meaning she did not receive the whole of this amount. So after you subtract 5%, she received, or he received, 95% of this money. So after the commission of 5%, he didn't get 100% of this money. So you get 95%. So you just take 100 minus 5% of this money. So that is 1,577,568. And these will give now the money that Bonja received after the commission. This will be 1,498,689 and 60 cents. So that is the amount he received after the commission. While in Kenya, he spent 3/4 of this money. He changed the balance to US dollars. So if he spent 3/4 of this money, that means he was only left with 1/4 of this money. So we get 1/4. So this will be the remaining quarter of this money. That is 1,498,689 and 60 cents. That is the amount that he'll be left with, because he spent 3/4 of that money, so was left with 1/4. So when we multiply out these one will give 374, 672 and 40 cents. So this is the amount that he was left with, and that is the amount that he converted. He changed the balance to US dollars. So we change this amount to US dollars. So look at the US dollar. It buys at 126 and 50 cents, sells at 131 and 50 cents. So which column are we supposed to use? Anytime you're converting the foreign money to Kenyan money, you're going to use the sell. So therefore, we're going to use this column here, the sell. So 1 US dollar sells at Kenyan shillings 131 and 50 cents. So what about the whole of this amount? 374, 672 and 40 cents. So this one you're going to divide. So we shall have 374, 672 and 40 cents divided by 131 and 50 cents. And these will give the remaining amount in dollars. It's supposed to give to the nearest dollars. So the nearest dollars, this one you get 2849.22. So to the nearest dollars you get $2849 US dollars. That is how you're supposed to solve that question. Find the value of x in the following equation. 49 raised power x plus 1 plus 7 raised power 2x is equals to 350. So to solve this question, look at the bases on indices. Look at 49, look at 7, and look at 350. So can they all be expressed to the same base in power form? Yes, it is possible for the left-hand side for 49 and 7, but it is not possible for 350. So what do you do in such a case? Now you're going to first write 49 raised power x plus 1 base 2, using base 2 in power form, using the base 7 in power form. That is a 7. 49 will be 7 squared, and then there is x plus 1 like that, then plus 7 raised power 2x is equals to 350. So once you've done that, of course, this will get 7 raised power 2x plus 2 plus 7 raised power 2x is equals to 350. So I want you to look at these. You can be able to split this one. This is the same as 7 raised to power 2x multiplied by 7 raised power 2. That is the same as 7 raised power 2x plus 2. And then plus 7 raised power 2x is equals to 350. So when you look at the left-hand side, there's something that you're going to note. Between these two terms, there's something common. So 7 raised power 2x is common. So you can factor it out. 7 raised power 2x is common. When you factor out that, you're going to remain with 7 squared. Then there is a plus. Here you'll get 1. That when you open these, this one will take you back to that. This one is equals to 350. So this will give 7 raised power 2x multiplied by 7 squared is 49. And then plus 1, this will be 50. Like that is equals to 350. So dividing both sides by 50, divide that side by 50 and this one by 50, you will end up with 7 raised power 2x is equals to, this will give 7. Now you can see the left hand side and the right hand side, you have the base, which is 7. This is same as 7 raised power 1. In that case, now you can get the solution. Just pick the powers. That is 2x is equals to 1. And for this, x will be given by a half. Determine the possible values of x which make the product of matrices T is given there and W to map triangle ABC on a straight line. So the first thing you're going to do in that question is getting the product of these two matrices. So let us go straight and get the product. So we want to multiply T, which is x negative 1 and 1 and 1 2. Want to multiply that one with, that is T. W, this is a 1 1 0, then x minus 1 1 and 2. So the first thing you're going to check whether these two matrices are compatible, whether it is possible to multiply them. We get the order of the matrix. The first one is 2 rows, 2 by 3. And then this one is 3 rows and 2 columns. So when you look at the number of columns, the first one is equals to the number of rows in the second one. They are compatible. And what you expect as the answer is a 2 by 2 matrix, 2 by 2 matrix. So the remaining ones, these and these, 2 by 2 give the solution. The solution should have a 2 by 2 matrix. Now, once you've done that, let us multiply. So the first row, row 1, multiply by column 1, this is x times 1, that will be x. Then plus 1 times 1, that is 1. Then 1 times 0, that will be plus 0. Now we go to row 1, column 2. So x times x minus 1, that will give x squared minus x, x squared minus x. Then plus 1 times 1, that is 1. Then plus 1 times 2, that is plus 2, like that. Then you go to row 2, column 1, negative 1 times 1, that is negative 1. Then 1 times 1, that is a plus 1. Then 2 times 0, that is 0. Then row 2, column 1, negative 1 times x minus 1, that will give negative x plus 1. Then 1 times 1, that is 1. Then 2 times 2, that is 4. So that is exactly what you get when you multiply. So you can simplify these. X plus 1 plus 0, that will give x plus 1. And then this will give x squared minus x plus 3. Then down here you have negative 1 plus 1 plus 0. This will give 0. And then this will give negative x plus 6. So that is what you get as a product. Now, from there, you're given that this product will map triangle ABC onto a straight line. That means that this transformation, we need to get the matrix of transformation that maps an object to 180 degrees. And which is that matrix? If you recall, the general matrix that transforms an object at an angle of 180 degrees, because that is what we mean by a straight line. Straight line means that he is going to do a transformation that will map that triangle into a straight line. So we need to get that matrix that represents half turn about the origin. And that matrix is given as negative 1, 0, 0, negative 1. That is the matrix that represents transformation that is half turn about the origin 0, 0. And half turn is actually 180 degrees, and that is what we mean by straight line. So therefore, when you look at this matrix, you notice that these elements in this diagonal are equal. They are equal, negative 1, negative 1. And therefore, we are going to get the value of x by taking these elements of this diagonal. And you're going to say that x plus 1, that one should be equivalent to negative x plus 6. And collecting the like terms together, you get 2x is equals to, this will be 5. And the value of x will therefore be 2.5. That is what you're supposed to do. Three interior angles of an irregular polygon are 130, 60 degrees, and 80 degrees, and all the remaining interior angles are 150 degrees each. Calculate the number of sides of the polygon, hence give its name. So before solving this question, you need to know how do you get the sum of angles, the interior angles of this irregular polygon. The sum of these angles is given by this formula, 2n subtract 4 right angles. That is how we get the sum of all the interior angles of this irregular polygon. Now let's get the sum. So we have 130 degrees plus 60 plus an 80, and all the other remaining interior angles are 150 each. So assuming that the number of angles, this one is very important to note, that the number of angles is equal to number of sides. So if this polygon has n sides, that means it has n angles, n number of angles. It has n sides, and therefore it has n number of angles. So if you already have the three angles, 130 and 60 and 80, then the remaining angles, if all the angles are n, and you already have the three of them, so the remaining angles we subtract 3. We are subtracting 3 because of these three, 130, 60, and 80, assuming that all the angles are n. So now this gives all these remaining angles are represented by n subtract 3, and each one of them is 150. Now that one now shows the sum of all the interior angles of this irregular polygon. So 130 plus 60 plus 80 plus all the other remaining angles, that is n subtract 3. Each of them is 150, and this one should give the sum, and the sum is 2n minus 4 right angles. So when you solve these now, we get n, it will give us the number of sides. So we can add 130 plus 60 plus 270 plus 80. This will give 270 degrees when you add that. And then plus 150 times n, this will be 150n. Subtract 3 times 150, that will be 450, is equals to, this is 180n minus 360, like that. So like terms together, so I'll take n together, so 180n minus 150n is equivalent to, I'm trying to take them to the right hand side, so this will give 360. So 360 plus 270 minus 450. So what I'm doing, I'm grouping them, the like terms together. So 180n minus 150n, that will give 30n is equals to, you can add these. So you have 360 plus 270 minus 450. So that gives 180. So n therefore will be 180 divided by 60, and this one n will give 6. So n is the number of sides, which I said is also the number of angles. If you have 6 sides, that means we have 6 angles. And which polygon is that has 6 sides? It is referred to as a hexagon. So that is how we're supposed to solve that question. Three bells ring at intervals of 30 minutes, 45 minutes, and 60 minutes. If they ring simultaneously at 7:30 a.m., at what time did they last ring together? So you need to understand this question. The question is asking about at what time did they last ring together. If they ring simultaneously at 7:30, so they ring at intervals of 30 minutes, 45 minutes, and 60 minutes. So the first thing we need to get is the time. If the time taken before those intervals, time taken before the bells ring together. And to do that, we shall get the LCM of 30, 45, and 60. So these will give us the time intervals in which these bells ring together. And this one will get the LCM. So let's get the LCM. We divide by 2. This will give 15, 45, 30. By 2 again, this will give 15. Dividing everything by 2, this will give 45. This will be 15. Then we divide by 3. This will be 5. This will be 15. this will be 5, 3 again, this will be 5 still, this will be 5, and then this one will be 5, then 5, 1, 1, 1. So this will give us the time, the interval in which they ring together. So we get this will be 2 squared times 3 squared times 5, and this one will give us 180 minutes. That is the interval in which these bells ring. So 180 minutes is the time taken before the bells ring, from first time to the next time. So 180 minutes is 3 hours. So they ring together after every 3 hours. So if they ring together after every 3 hours, and you are given that they will ring simultaneously, as 7:30 a.m. What time did they ring last? So to get that, you're going to subtract. So you're going to simply take 7:30 and then we subtract, because the question is what time did they last ring together. So we subtract 3 hours, and this will give 4:30 a.m. Now, given that sine of 3x minus 35 divided by cosine of x plus 20 is equals to tan 45, and x is an acute angle, find the value of tan x plus 15, giving the answer correct to two significant figures. Now, to solve this question, there's something that you need to understand. When you look at this question, you need to understand from the spatial angles, tan of 45. So using this triangle here that I'm going to draw here, able to assist you to get the tan of 45. So this one is an isosceles right angle triangle. So this angle is 45 degrees and this angle is 45 degrees. So this side is 1, this side is 1, and this one will be root of 2. So if you get the tangent of 45 degrees, this will be opposite of adjacent. Any angle that you use here that is 45 degrees, you get tangent of that angle to be 1. So that means that sine of 3x minus 35 divided by cosine of x plus 20 degrees is equals to tangent of 45, which is 1. Now, after getting that, you can cross multiply. So we cross multiply these. These will have a sine of 3x minus 35 is equivalent to, cross multiply the other side, cosine of x plus 20. Now from these, there's another property that you're going to use. The moment you find you have cosine and sine equated together, we remember this, that given the sine of any angle is equivalent to cosine of any angle, then it means that when you take A and B and get the sum of that, you should get 90 degrees. So in this case, A is here, 3x plus minus 35. So 3x minus 35 degrees. Then we add B is x plus 20 degrees. That should give 90 degrees. So 3x plus x, this will give 4x. Then minus 35 plus 20, that is minus 15 degrees, is equals to 90. So therefore, 4x is equals to 105 degrees. So x, therefore, 105 divided by 4, and this will give, when you divide, 26.25 degrees. Now the question is, get the tan of this. Now you have x, so tangent of x plus 15 degrees will be tangent of x is 26.25 plus 15 degrees. And when you work it out using our calculator, this will be tangent of 41.25, which will give 0. You're supposed to give this one correct two significant figures, 0.88. Complete the sketch of a solid below, showing both the visible and the hidden lines. So I'll use a pair of compass to do this. So the first thing, we want to get this length. We want to get the length that will be here. So we take this measurement. Just look at a pair of compass. So I want to take the length of this line. So taking the length of that line. So with that length, stand here, stand at that corner, and then you mark an arc there. Then the next thing is to take this height. So take this height that is here. Take that height as well. The length of that height. And then transfer it to this. So standing at that point. And then you cut that arc like that. So by doing so, you'll now join, you have a straight line that you're going to join from this point all the way to the point of intersection of that arc. And then you shall have another one from this point of intersection of that arc straight downward there. So that will be somewhere there. Let me join this one properly. So you'll have one from this point all the way to, let me use a ruler for that. So you can use a ruler for that. So join that line like that. Then from there, the next one that you need to get is the hidden ones. So you need also to take this measurement here. So from this point, you take the whole of this measurement. At that point, you transfer that to stand at this point. Then mark an arc. Then from there, you take this the measurement. Show you. So this measurement here from this corner point. To that point there. Take that, then you transfer it here. So standing in that corner, then you can cut that arc like that. Then from there you can join this point. This will be continuous line, this point, that point, and then this other that is here. So from this point again to this one. So let me use a ruler for that. So join that like that. And then now what is remaining is we have another one here. We have these lines. So you need to have these lines transferred to this point here. And that one, this is what you're going to do. And also the hidden line, we can start with the bottom line that is passing through this point. So to get that one, again, we are going to get this measurement here, measurement of this line, that line, and then we stand at this point, and then we can mark an arc there, like that. And then from there we can take this measurement, of this line, that measurement, we stand at this point, then cut this arc like that. Then from there we can join a straight line here from this point up that point, then from this point use a ruler for this one. So like that. So once we've done that, we are only remaining with these sides here. So we need to get this V shape. So to do that, we shall take a pair of compass and we take this measurement. Let's take this measurement here, that measurement, and then with that we can stand at this point, and then we mark an arc like that, and then from there we can take the other one from that point to this point again. We take that, then standing at this point we can cut that arc like that. So by doing so, we shall have a line. We join this point here, this point of intersection like that, and then the other one like that. So I think the only thing that is remaining is a line that joins this point. And draw this line here at the back. So from this point to that point there. So let me use a ruler for that. So we need these. That one. So join that one using straight line like that. Now we have everything complete. The only thing that is remaining is now showing the hidden lines. The hidden lines, we have not shown them correctly. So I want to identify one line that we don't require. We don't require this one, so that one we can grab it. We don't require that. So that is the line that we don't require. So we don't require that line. So the broken lines are here. So these will be not that one, but this one. The line, this will be a broken line. So it is good to indicate that that is a broken line. Then also these ones will be, this is a hidden line like that. Another one is this right here, that one also a broken line like that, and also this one that is here. So now that is the complete sketch of the solid. Now we need to label. Can label, this will be point E, this one will be, this is A, this is B, C is there, D is there, E is there, F is here, I is there, H is here, then G is there. So that is how you're supposed to do that. Find the equation of the tangent to the curve y is equals to x squared minus 2x plus 5 at x is equals to -1, leaving the answer in the form y is equals to mx plus c, where m and c are constants. So to solve this question, let me first sketch, just a sketch, that is the curve, and then we have the tangent. So the curve is here, and then the tangent is here, and this point of contact between the curve and the tangent is x is equals to -1. So you need to get the equation of that straight line, which is the tangent. And to do that, you require to have the gradient, that is the first thing. So what you're going to do, we shall get the gradient of that tangent using this point of contact. So the gradient at this point, and that gradient will be given by the gradient of the curve at that point, that is x is equals to -1. That will give the gradient of the tangent, since that is a point that is common between the tangent and the curve. So once we get the gradient of the curve at that point, that would also be the gradient of the tangent. So how do you get the gradient of the curve at that point? By taking the function of the curve and then we differentiate it. So y is equals to x squared minus 2x plus 5. When you differentiate these, it will give us the gradient function, which you're going to use to get the gradient at that point. So differentiate this one with respect to x, you get 2x subtract 2. So that is the gradient function. So now to get the gradient at this point, x is equals to -1, we simply substitute x is equals to -1 in this expression. So 2 to brackets -1 minus 2. So this will give -4. So the gradient of this curve at this point is -4. This point is -4, which will also be the gradient of the tangent, and that will be -4 as well. So once we've done that, now we have the gradient of the tangent, which is -4. We need to get at least a point, and since we have the x coordinate of this point of contact, to get the y coordinate of that point, which is common to the curve and common to the tangent, we are going to use this function y is equals to x squared minus 2x plus 5, and you're going to substitute when x is equals to -1. So what is y? So this would be -1 squared minus 2, -1 plus 5. So this will give the y coordinate of that point of contact, and this will give 8. So that means that this point therefore will be -1, 8. So now we have the gradient, which is -4, and we have one point, which is -1, 8. So now we can, using those two, we can get the equation of the tangent, because we just need to introduce another general point, xy. Let's introduce another point, xy, and use this to get the equation. So let's get the gradient using -1, 8, and xy. So change in y, that is the gradient, y subtract 8, but change in x, which is x subtract -1, which is x plus 1, is equals to -4. So you can cross multiply, and this one will give y subtract 8 is equals to -4 times x plus 1, that will be -4x subtract 4. And these will give y, if you reorganize this in the required format, y is equals to mx plus c, y is equals to -4x, then minus 4 plus 8, that will give +4. So that is the equation. Using a ruler and a pair of compasses only, draw a parallelogram PQRS in which PQ is equals to 8 centimeters, QR is equals to 6 centimeters, and angle QPS is equals to 75 degrees. Draw a perpendicular from S to meet PQ at N. Measure the length SN. Now the first thing I'll do is first to sketch that parallelogram. These are going to do it. So just a small sketch here. So something like this is the sketch. And in this sketch, so we have PQ, so P, Q, and R, S, in which QR is equals to 6 centimeters. QR is 6 centimeters. Angle QPS is this angle. That is 75 degrees. And the PQ is 8 centimeters. Then you're supposed to drop a perpendicular from S to meet. So you need to drop it like that to meet at this point. So this line is parallel to that, and also this one is parallel to this one and equal. So that means if this is 8, this one should be 8, and this one should be 6. Opposite side of a parallelogram are equal and parallel. So after doing that, we can now draw a sketch of that. You can draw a sketch of that using a ruler and a pair of compasses. So you start by drawing a straight line so that I can construct the angle of 75. So draw a straight line like that. And then I can mark a point here. This is where I want to construct, that is point P. So to construct an angle of 75, I will construct an angle. There are so many ways of doing that. So I can construct an angle of 60 on the left hand side. So let me do it step by step. So I can construct an angle of 60, an angle of 60 on this side. Look at the side where we require 75. You need to be very keen with that. So I want to construct 60 on this side. So let me repeat that. So construct an angle of 60 on this side. So mark an arc there with the same radius. The same radius is stand at this point, and then you cut that arc. So that will be 60. So with 60, I'll remain with 60 on the other side. So then I will bisect that angle of 60 degrees. So let me first join. So this one, so that will be 60 degrees. But remember, I don't want 60. I want 75. So the moment you get 60, you can bisect that angle of 60. So we can bisect this angle. So and to bisect that angle, you can use these arcs. So you can stand here, make these arcs. So I'll use these arcs that are here. So let me pull this a little bit on this side. So I'll use these arcs that I made here. So standing at that point, let me use any radius here. So I mark an arc there. Then with this standing on this arc here, cut that arc. So I have to make this arc to be a little bit bigger. Make this one to be a little bit bigger here. So like that. So when I join this one, this point here, the point of intersection of that arc, now I'll be able to have an angle of 30. So this will be 30 and this will be 30. So you notice now I have on this side, I have 120. So 120 plus 100 and plus 30, that will be 150. So if I bisect 150, I'll get 75. So you can see I have 120 plus 30, that is 150. Then 150, you bisect it and you get 75. So I'm going to bisect that. So standing at this point, to bisect that, standing at that point, you mark an arc there, and also you mark an arc here. Then adjust the radius. So standing on this arc again, that arc there, you can mark an arc there, and then with the same radius and at that point, and cut that arc. So now the line that I'm going to draw from this point, straight line connecting that point, that will be 25. So this will be 75 degrees. So the whole of this angle here, this will be 75 degrees. So this angle here, that angle is 75. So I already have 75 degrees. So the next thing that you need to get now is that measurement 8 centimeters. So 8 centimeters. So point P is here. So this is point P. So I need to get 8 centimeters. So 8 centimeters. So that is 8 centimeters. So you mark an arc there. And so this will be point Q. That will be point Q. Then PS is 6 centimeters. So PS is 6 centimeters. So standing at P should take 6 centimeters. 6 centimeters is there. So we mark that. So that point will be S. So that point is S. Then from there, we need SR. SR is equals to PQ. SR is equals to PQ is equals to 8. So I stand at P and PQ. PQ will be equal to SR. So remember that was 8 centimeters. So you transfer that. So from this point, make sure you mark an arc like that. Now we need QR. So QR is the same with PS. So we just take the measurement PS, which was 6. That was 6 centimeters. Or 6 centimeters. So transfer that on here, standing at Q. Standing at Q, you mark an arc there. So when you do that, now this point of intersection will give R. So this is where we shall have R. So we can join that. So you can join it there. Our parallelogram is now complete, whereby this side is parallel and equal to this. So this is 8 centimeters. This one is 8 centimeters. And then this side is 6 centimeters. And this one is 6 centimeters, like that. The other question is you're supposed to drop a perpendicular from S. So drop perpendicular from S. Stand there with your pair of compass at S to meet PQ at N. So this is how you drop perpendicular from S, standing at S. Make sure you open your pair of compasses and mark 2 arcs. So make sure you mark 2 arcs on line PQ extended. So mark an arc there and another arc there. You can see those 2 points. Then from that, those 2 arcs that you've made, you stand on that point. And then you mark another arc there, then stand at the other arc, the point on the other arc you made, and then cut that arc like that. So after doing that, now you can join this point with the point of intersection of that arc. So join that point like that. So you've dropped perpendicular. It is meeting this line here at N. So this is supposed to be point N, like that. That is N. And you're supposed to measure SN. That is from the question, measure the length of SN. And the SN will be this distance here. So I'll use a pair of compass. Mine is calibrated. So just standing at that point. So I'll take that measurement. So that is giving 5.9. So SN is equals to 5.9 centimeters. And that is how you're supposed to solve that question. A bus traveling at an average speed of x kilometers per hour left station at 8:15 a.m. A car traveling at an average speed of 80 kilometers per hour left the same station at 9 a.m. and caught up with the bus at 10:45 a.m. Find the value of x. Now we have 2 vehicles here. The bus that is traveling at the speed of x kilometers per hour. So this one is the bus traveling at x kilometers per hour. It left the station at 8:15 a.m. Then the car traveling at an average speed of 80 kilometers per hour. This is the car. It left the station at 9 a.m. Then we're given that it caught up with the bus at 10:45. So the car is the one that caught up with the bus. So we can assume that this is the meeting point. So this is the point where it caught up with the bus. So this is the meeting point of the two. So we need to find the value of x, which is the speed of the bus. Now to do that, the first thing that we need to do is to get the relative distance of these 2 vehicles from the start of the journey to the meeting point. We need to get this distance from the start to the meeting point. So how do we get that relative distance between them? The relative distance we are going to use the car, because already we know the speed of the car. So to get that distance, we are going to use distance is given by speed times the time, and this time we're going to use the speed of the car, because that is what we know. We don't know the speed of the bus. We're supposed to get that, and therefore the speed of the car is 80 kilometers per hour times the time taken by the car. That is, it began the journey at 9 a.m. So from 9 a.m. to the meeting point, that is at 10:45. That is the time taken. So this will give 80 kilometers per hour times, just get the difference, 10:45 subtract 9 a.m. That will give 1 hour 45 minutes, 1 3/4 of an hour, and this will be the same as 7/4. That will be 7/4. So we multiply these, so we get distance, that the relative distance will be 80 kilometers per hour times 7 divided by 4 hours. So this will give 140 kilometers. So that is the distance between the two, from the start of the journey, the point where they began the journey, up to the meeting point. So now we have that distance still the same. So this distance is 140 kilometers. Now, having that, we can now get the speed of the car. The speed of the car will be obtained by, we get the distance, which is the relative distance, divided by the time taken. So the relative distance between the two is 140 kilometers, and then we divide by the time taken by the bus. Time taken by the bus, that is from 8:15 to the meeting point. The meeting point is 10:45. They met at 10:45. So we get that. So this will give 140 kilometers divided by, let us subtract 8:15 to 10:45. That will be 2.5 hours. 2.5 hours. So this will give 140 times 2/5. And these will give, work out, this will give 56 kilometers per hour. When you work out these 140 kilometers divided by 2.5 hours, that will give 56 kilometers per hour, and that is the value of x. And the speed, that is the speed of the bus, 56 kilometers per hour. A solid cone of height 12 centimeters and radius 9 centimeters is recasted into a sphere. Calculate the surface area of the sphere. One important thing that you're supposed to understand is that if the solid cone is recast into a sphere, then there's something that is common, and that is volume of the cone will be equal to the volume of the sphere. That is, if the cone is recast into the sphere, the volume of the two will be the same. So one thing that you need to do is to get the volume of the cone and equate that with the volume of the sphere. So how do you get the volume of a cone? The volume of a cone is given by this formula, a third pi r squared height. The volume of the sphere is given by 4/3 pi r cubed. So what do we have for the cone? We have the height of the cone, and you have the radius, so you can get the volume of the cone. So for the cone, we have a third times pi, which is 22/7, times the radius, which is 9 squared, times the height, which is 12. So we work out that, and this one is going to give, when you multiply out, this will give 1018 4.29 centimeters squared. Then for the sphere, we have 4 over 3 pi r squared, not pi r squared but pi r cubed, and this one will be 4/3 times 22 over 7 times r cubed. Why r cubed? Because for the sphere we don't have anything given, any measurement given. We don't have the radius, so therefore we need to equate the two. We need to take whatever we got here, that is the volume of the cone, and then equate that to the volume of the sphere. So let me do that. So the volume of the cone, which is 4/3. So we can work out this. You can simplify this one further. 4/3 times 22 over 7. So you can work out that, and this one will give. So when you work out these 4/3 times 22 over 7, that will give 4.19 radius cubed. So we need to equate the two. Volume of the sphere, which is 4.19 r cubed, is equals to the volume of the cone, 1018.29. So you want to get the radius, because you have to get this, it is unknown. So radius cubed is equals to 1018.29 divided by 4.19. So radius cubed, we can go straight and get the value of these. We can get the cube root. So for us to get radius, we are going to get the cube root of the whole of these. So 1018.29 divided by 4.19. So radius, working out this one using a calculator, the radius will be given by 6.24, because this will give 243. So this will give 243, the cube root of 243.02. And when you get the cube root of that, if you get the cube root of that, this will give 6.24 centimeters. Now we have the radius of the sphere. Now we need to calculate the surface area of the sphere. So how do you get the surface area of the sphere? Surface area is given by 4 pi r squared. 4 pi r squared. So this will be 4 times 22 over 7 times radius squared, 6.24 squared. And these will give 489.5 centimeters squared. Points A, -1, -6, and B, -4, -5 are mapped onto A prime, 5, -5, and B prime, -1, -3, respectively, by an enlargement. Find the coordinates of the center of enlargement. Now to find the coordinates of the center of enlargement, given the point A and B and also their images, the first thing we need to get is the scale factor of enlargement. So we need to get the scale factor of enlargement. And how do we get the scale factor? You need to know these. You let the scale factor of enlargement be represented by K. So this is how you get a scale factor of enlargement, by getting the image distance divided by the object distance. So in this case, we shall use the image distance to be represented by A prime, B prime, and then the object distance to be AB. So therefore, if you cross multiply these, you realize you get K multiplied by the object distance. I'll use OD, object distance, is equals to image distance, like that. So if I substitute my values here, I'll get K object distance, which is AB, is equals to image distance, which is in this case, because I have A and B, this will be A prime, B prime. That is what I need to get. So therefore, we need to get AB. So how do you get AB? I'll write these ones, A, in terms of column vectors. So A is -1, -6, so -1, -6, like that. And B is -4, -5, like that. So to get AB, I'll get B, the column vector B, subtract A. So therefore, K, this will be K, and then I get AB. I'm here, AB. So AB, to get that displacement AB, I take B, that is -4, -5, and then you subtract A, which is -1, -6, like that. So let me enclose this one like this, is equals to A prime, B prime, A prime, B prime. So again, for that one, I need to get the column vector. A prime is 5, -5. B prime is -1, -3. So therefore, for this one, I will have A prime, B prime. I take B prime, that is -1, -3. Then subtract A, 5, -5, like that. So that is what I need to work on. So very fast, this will be K. So when you work out everything there, -4, subtract, this is a -4 plus 1, that will be -3. Then -5 plus 6, that will be 1, is equals to -1, subtract, this will be -6, -3, subtract -5, this will be 2, like that. So multiplying everything, this will give -3K is equals to -6. So K is equals to 2. And also the bottom line here, if you work it out, you still get K is equals to 2. So K is the scale factor of enlargement, and you already got that as 2. So now, after getting the scale factor of enlargement as 2, now there's something else that you need to do in order to get now the center of enlargement. And this is what you're going to do. You'll get the scale factor of enlargement when you multiply the object to the center, that distance, object center distance, that should be equivalent to the image to the center. I repeat, so if you take the scale factor of enlargement, that is K, multiplied by object to the center, that distance, that's equivalent to image to the center. Now in this case, I'll let the center be xy. You can write this one in column form, that will be xy, like that. So therefore, if I take K, and then I can choose the point that I'm going to use. So from the object to the center, so I'll use A as my object, A as the object, and center as xy. So that distance will be given by y subtract -6, which is y plus 6, then x subtract -1, so x minus, so that will be x plus 1. So because it is x subtract -1, that will be x plus 1. So after getting that, this one is equivalent to the image, the center. So for the image, I'll use A prime and the center xy. So I want to get that distance. So that will be y subtract -5, that will be y plus 5. and then x is x subtract 5. So x subtract 5, like that. So open these brackets, you get this is, and remember that k, we can substitute k. K is 2. We got the k as 2. So don't forget that, the scale factor of enlargement. So this one is 2. So opening this one, you get 2y plus 12 is equals to y plus 5. So this will give y is equals to 12, take this one to the other side, 5 minus 12, that will be negative 7. Then the bottom, that is 2x plus 2 is equals to x minus 5. So this one will give x is equals to minus 7. So now you have y coordinate of the center and x coordinate of the center, and therefore the center xy will be given by negative 7, negative 7. That is simply how you're supposed to do it. In the figure below, PQRS is a trapezium with QR is parallel to PS. QR is equals to 6 centimeters, RS is equals to 4 centimeters, QS is equals to 9 centimeters, and PS is equals to 10 centimeters. Calculate the size of angle SQR. So SQR is here. SQR is this angle that you need to calculate. So look at that triangle, triangle RQS. So you have all the sides, so it is possible to get that angle using the cosine rule. So let's call this side that is opposite R, small r, side that is opposite S, small s, the side that is opposite Q, small q. So in order to get that angle Q, we are going to use the cosine rule, and this is how it states that Q squared is equivalent to S squared plus R squared minus 2SR cosine of Q. So what you need to do is just substitution. So Q squared will be 4 squared is equals to 6 squared plus 9 squared minus 2 times SR, that is 2 times 9 times 6 multiplied by cosine of Q. So this will give 16 is equals to, when you add everything here, you get 6 squared plus 9 squared, that will give 36 plus 81, that is 117. Then minus, this 9 times 6 is 54, 54 times 2, this will give 108. That will give 108 cosine of theta, like that. So from there, you can make cos theta the subject. You can make it the subject. So you'll have 108 cosine theta. You just simply taking this one to this side, and then 16, you take it to the other side. This is equivalent to 117 subtract 16. So this will get 108 cosine of theta is equals to, so 117 subtract 16, this will give 101. So this one is 101, like that. So cosine of theta, make it the subject, this will be 101 divided by 108. So from there, in order to get the angle theta, you get the cos inverse of cos theta is theta, then the cos inverse of 101 divided by 108, like that. And this one will give 20.74 degrees. So that is what you get. Now that is the angle, that is the required angle. And the next thing that you need to get is the area of triangle PQS. So look at that triangle. triangle PQS. So you need to get the area of that triangle. So one thing that you need to realize is that this line is parallel. So this line is parallel to, that is a QR being parallel to PS, and therefore QS will be a transversal, and you know the properties of angles in a transversal. So if this angle is 20.74 degrees, also this one is alternate, so it will be 20.74 degrees. The reason, you have QR being parallel to PS, and therefore QS is a transversal. Now having that, look at triangle PQS now. You have two sides and an included angle. So there's an included angle there. So you use the sine, this formula, a half AB sine theta. So area is equals to a half AB sine theta, and this will be a half times the two sides given between the angle, 9 times 10 times sine of 20.74. So when you work out that, half times 9 times 10 times sine of 20.74, that will give 15.94 centimeters squared. A right conical frustum of the base radius 7 centimeters and the top radius 3.5 and height of 6 centimeters is stuck onto a cylinder of base 7 centimeters and the height of 5 centimeters, which is further attached to a hemisphere to form a closed solid as shown below. So the diagram is there. Determine A, the height of the original cone where the frustum was cut from. That is the first one. Then the second part, part B, the volume of the solid. And then part C, the surface area of the solid. And those are the questions you're supposed to do. So you go to the first part. You're supposed to find the height of the original cone where the frustum was cut from. So we'll begin by completing the frustum. Before it was cut, it was looking like this. Just completing it. So before it was cut, it was like that. I can also add this height there. So that is how it was. So you can see this part, this one is a full cone. So the original cone is what we need to get. We need to get the height of the original cone. So when you look at the original cone, the height is this. From this point up there though. So this is the height. So we can let this particular height of the smaller cone. You can see we have two cones, the larger one, and then we have the smaller cone at the top there. So we can let this small height to be represented by X. So that the larger height, that is the bigger height, will be 6 plus X. So it will run from this point to the top. So after doing that, now what is going to assist us to get the height of the original cone is similarity. The reason is because we have two cones here. We have two similar figures, and that is two cones. You can see we have a bigger cone and a smaller cone. So using similarity, we can calculate the height of the bigger cone. So we can use the radius. So we have the radius of the bigger cone. The radius of the bigger cone is 7. So this is the same, this 7. And then the smaller one is 3.5. So we can use similarity. So let's use that. So radius of the bigger cone divided by radius of the smaller cone divided by the height of the bigger cone over the height of the smaller cone. So let us replace these. So radius of the bigger cone is 7. Then the smaller cone is 3.5 is equals to height of the bigger cone is 6 plus x. 6 plus x. Then the height of the smaller one is x. So you need to be very careful to identify that. Smaller cone, height is x. The bigger cone is 6 plus x. So using these, we'll be able to get the value of x, which will assist us to get the height of the original cone. So we cross multiply here. So we get 7 times x, that will give 7x is equals to 3.5 multiplied by 6 plus x. So this will give 7x is equals to 3.5 times 6, that will give 21, and then plus 3.5x. So collect the x's together. You'll have 3.5x is equals to, this will be 21. So from here, the value of x, divide both sides by 3.5, and this will give the value of x to be 6. So after getting the value of x to be 6, you're going now to get the bigger height, the height of the bigger cone, which is 6 plus x. So remember, height of the bigger cone is 6 plus x. So this will be 6 plus 6, and this will give 12 centimeters. We got part B, the volume of the solid. The volume of the solid. So here we have 3 different shapes. We have the frustum. And then we have the cylinder. And then we have the hemisphere. So we need to get the volume of each of that. Now we are going to start with the volume of the frustum, and to get the volume of the frustum, we are going to get the volume of the bigger cone, subtract the volume of the smaller cone. So the volume of the bigger cone. So how do you get volume of a cone? Volume of a cone is given by a third pi r squared height. So we get it by volume is equals to a third pi r squared height. So let us look at what we have. Do we have everything? For the bigger cone, we have the height, which is 12. We have the radius, so we have everything. The smaller cone, again, we have the height, which is x, and then the radius there. So we can get the volume of the cone. So for the cone, we can start. So this will give a third multiplied by pi, which is 22/7 times radius squared, that is a bigger cone, times the height, which is 12. Then we subtract the smaller cone, that pi r squared, the radius is 3.5 times the height, which is 6. So use a calculator to work out these. So the volume of the bigger cone, subtract the volume of the smaller cone. So the whole of these are that times 22/7 times 7 squared times 12. These will give 616 centimeters squared. And then a third times 22/7 times 3.5 squared times 6. These will give 77 centimeters squared. When you subtract, you'll get 539 centimeters squared. So that is the volume of the frustum. The next one is the cylinder, and the cylinder has a radius of 7 and the height of 5. So cylinder, volume of the cylinder is given by pi r squared height. So we have 22/7 times radius is 7 times the height, which is 5. So when you multiply these will give 770 centimeters. Or this is a cubed, not squared. 539 centimeters cubed, and then this one is 770 centimeters cubed. So that is the volume of the cylinder. Now let's go to the hemisphere. The hemisphere is the next. So for the hemisphere, how do you get the volume of a hemisphere? The volume of a hemisphere is given by half times 4 over 3. So the volume of a sphere is given by 4 over 3 pi r cubed. So if you multiply that by half, because a hemisphere, you'll get 2/3 pi r. It's given by 2/3 pi r cubed. So 2 over 3 pi. And then radius is, the radius of that sphere is 7. So this will be 7 cubed. So when you multiply these, this will give 718.67 centimeters cubed. So now we have the volume of the three of them. So now to get the total, we simply need to add the volume of the first term, which is 539 centimeters cubed, plus the cylinder, which is 770 centimeters cubed, then the hemisphere, which is 718.67 centimeters cubed. When you add these, you're going to get 27.67 centimeters cubed. That is the volume of the solid. Now we go to the other question, the surface area of the solid. The surface area of the solid. So how do you get the surface area of the solid? So again, we are going to begin by getting the surface area of the first term. And the surface area of first term is given by pi r l. So what we don't have, we have the radius, we don't have the l. L is the slant height of these. So these are slant height. We need to get the slant height of the bigger cone, which I will denote by capital L. And to get that, we're going to use this triangle here. You can use this triangle. Base 7, then the height is 12. You can see that, So use this triangle. The height is 6 plus 6, that is 12. And then the base is 7. So we can get the hypotenuse. And the hypotenuse using Pythagoras theorem will be given by 12 squared plus 7 squared. And that is base 7 squared, then the height is 6 plus 6, 12. So these will give, if you work out these, 12 squared plus 7 squared, get the square root of that. That will give 13.89. Then we get the slant height of the smaller cone. The slant height of the smaller cone is this one here, the smaller cone there. So you're going to use the same thing, the same concept, that is Pythagoras theorem. So this one, we have 6 squared, that is the height, plus 3.5 squared. So 6 squared plus 3.5 squared. And then you work out that 6 squared plus 3.5 squared, you get a square root that will give 6.946 centimeters. Now we have the slant height of the two. So now to get the surface area of the first term, we're going to get the surface area of the bigger cone, which is given by pi times r, the radius of the bigger cone. Forget the radius of the bigger cone was 7, times the slant height of the bigger cone, L, that is 13.89. 13.89. So that will give the surface area of the bigger cone. Then subtract the surface area of the smaller cone. The radius of the smaller cone is 3.5. And then the slant height of the smaller cone, we got it is 6.946. 6.946 for 6. So work out these. So this one will give 22 over 7 times 7 times 13.89. That will give 305.58 centimeters squared. Then the smaller count, 22 over 7 times 0.5 times 6.946. That will give 76.41. When you subtract these, you will get 229.17 centimeters squared. So that is the first term. So we go to the cylinder. How do you get the surface area of the cylinder? Surface area of the cylinder. And for the cylinder, you should be, because this one is a solid, we only be interested with the curved part. This one is a solid. We only interested with the curved part. Now we are not going to add the circles. This is a solid. So how do you get the curved surface area of a cylinder? How do you do that? So that one, you know that it is given by this formula, either 2 pi r. You can use either 2 pi r or pi dh. Can use these, either of these two. So I use pi dh, so 22 over 7 times diameter. The diameter, the radius is 7, so the diameter is 14 times the height, which is 5. That cylinder. So just look at that cylinder, you see that. So this one will give, when you multiply, this will give 220. This will give 220 centimeters squared. So note that. Now remaining with the hemisphere. How do you get the surface area of the hemisphere? The surface area of a sphere is given by 4 pi r squared. That is sphere. So for a hemisphere, we're going to use half multiplied by 4 pi r squared. That will be 2 pi r squared. That is how we get the surface area of a hemisphere. So this will be given by 2 times pi 22 over 7 times the radius of the hemisphere is 7 squared. Just look at it here. It is here. You can see it is 7. And when you multiply these, you get 308 centimeters squared. 308 centimeters squared. Now we get the total surface area. We start with the first term, which is 229.17, plus the cylinder, which is 220, plus the hemisphere, which is 308. And when you add these, you get 757.17 centimeters squared. The equation of a curve is y is equals to x cubed plus 2x squared. Part A, find 1. The x-intercept of the curve. 2. The y-intercept of the curve. B, part 1. Determine the stationary points of the curve. And for the next part, for each point in B1 above, determine whether it is a maximum or minimum. And then lastly, sketch the curve. So let's go to the first part. The first part, you're supposed to find the x-intercept of the curve. So given the equation of the curve is there. So what you're supposed to know is that at x-intercept, so at x-intercept, y coordinate is equals to 0. So you simply need to substitute y with 0 in that function to get the x-intercept. That is the point where the curve cuts the x-axis. So substitute y is equals to x cubed plus 2x squared when y is equals to 0. So y, which is 0, is equals to x cubed plus 2x squared. So you can solve for x here. So factorize. X squared is common. You remain with x plus 2, and this will give either x squared is equals to 0, and this one x will give 0, or x plus 2 is equals to 0, so x is equals to negative 2. So you have 2 points at which this curve cuts the x-axis, that is x is equals to 0 and x is equals to negative 2. So therefore the x-intercepts will be x is equals to 0, then y is equals to 0 when you use this point, x is equals to 0, and the other one when x is equals to negative 2, y is equals to 0. So there's the x-intercept. Then the y-intercept, what you're supposed to know is that at y-intercept, x is equals to 0. So you simply need to take this function. So take that function y is equals to x cubed plus 2x squared, and then substitute x with 0. That is the where. When you're getting the y-intercept, you're getting where, the point at which the curve cuts the y-axis. So the function is y is equals to x is equals to 0. When you substitute there, you get y is equals to 0. So therefore, the y-intercept will be when x is equals to 0, y is equals to 0. And what we've done is simply looking at this function, y is equals to x cubed plus 2x squared, that, and then when x is 0, that is that y-intercept, when you substitute in this function, that is when you get y is equals to 0. So therefore, x is equals to 0, y is equals to 0, 0, 0 is what you're supposed to give. That is the point where the curve cuts the y-axis. Part B1. Determine the stationary points of the curve. Now, one important thing you're supposed to know when you're calculating stationary points is that at stationary point, the gradient is 0. And so what you're going to do, we're going to take the function of this curve, y is equals to x cubed. So y is equals to x cubed plus 2x squared. So to get the stationary point, we're going to get the gradient function of this curve, dy dx, differentiate this one with respect to x. You get this will be 3x squared plus 4x, like that. So when you differentiate it like that, this will give you the gradient function. And you said that at stationary point, the gradient or dy dx is equals to 0. So simply, you're going to take this, that is 3x squared, that is a gradient function, which is 0 at stationary points. So this will give you the value of x, the x coordinate of the stationary points. So you solve this, what is common, x is common. We need 3x plus 4 is equals to 0. So working out this, you get x is equals to 0, and also 3x plus 4 is equals to 0. This will give x to be negative 4 over 3. So these are the x coordinates of the stationary points. We got that. The x coordinates of the stationary point. Now we need to get the corresponding y coordinate. So when x is 0, what is y? So you simply take the function y is equals to, remember we have the function here, x cubed plus 2x squared, x cubed plus 2x squared. So when x is 0, when you substitute here, y will be 0 when you substitute x with 0 in this function. So that means that the first stationary point will be therefore given by when x is 0, y is 0. Now the other one, you get it when x is equals to negative 4 over 3. What will be y? So y is equals to x cubed plus 2x squared. You just substitute. X is negative 4 over 3 plus 2 negative 4 over 3 squared, like that. So these will give, when you work out this one using a calculator, you will get y will be 32 divided by 27. 32 divided by 27. That is y. So therefore, the next stationary point when x is negative 4 over 3, y will be 32 divided by 27. So now we have the two stationary points. So we have 0, 0, the first stationary point, and the other stationary point is negative 4 over 3, 32 divided by 27. We go to the next question. For each point in B1, determine whether it is maximum or minimum. So those stationary points that you have obtained, that is 0, 0, and negative 4 over 3, 32 divided by 27. You're supposed to determine whether these points are maximum or minimum. Now the easiest way to do this is by getting the second derivative. Remember, we got the first derivative. The first derivative of the function dy dx. We got the first derivative as it is here. We got it here. It is here. Actually, it is here. The first derivative was 3x squared plus 4. 3x squared plus 4. That is the first derivative. 3x squared plus 4. 3x squared plus 4. Now we get the second derivative. The second derivative, we differentiate this one again. This will give 6x plus, this was 3x squared, 3x squared plus 4x. That was this first derivative. When you differentiate that one once, it is here 3x squared plus 4x. So you differentiate it again to get the second derivative, and the second derivative is 3x squared. It will be 6x plus 4, like that. So from there, you want to test the first point. The first point is 0, 0. So we use the x coordinate of the first one. So the x coordinate, that is when x is equals to 0, what will be the gradient, the second derivative? When you substitute here, you get 6, 0 plus 4. So this will give 4. And this value is greater than 0 or greater than 1. So what we do, if the second derivative, now do you know this? If the second derivative, let me write it here. If the second derivative is greater than 1, then that one is taken to be a minimum point. That is taken to be a minimum point. If the second derivative is greater than 1, then that is taken to be minimum point. And therefore, this second derivative after substituting x is equals to 0, that is from the first stationary point, we got 4, and that is greater than 1, and therefore 0, 0 is a minimum point. Now let's go to the other one. The other one is when x is negative 4 over 3. So we substitute this one in the second derivative. The second derivative is 6x plus 4. So 6x is negative 4 over 3 plus 4. What do you get in this? So this will give negative 4. So if the second derivative is less than 1, then this one is a maximum point. It is a maximum point. So therefore, this point, that is negative 4 over 3, then 32 divided by 27, this one is a maximum point. So if the second derivative is less than 1, it is a maximum point. So we have determined the nature of those points by using the second derivative. Now the last question is sketching the curve. We sketch the curve. Now when sketching the curve, you need one, the intercepts, and two, the stationary points. So those are the two things that you need to sketch the curve. So remember the first part we got all the intercepts. The intercepts were 0, 0. They're here 0, 0, negative 2, 0, 0, 0. So basically we have 2 points, 2 x-intercepts and y-intercepts. I mean we have 2 intercepts, that is 0, 0 and negative 2, 0. So those are the intercepts that you're going to use. 0, 0 and negative 2, 0. 0, 0 and negative 2, 0. And then the intercepts, not the intercept, but the stationary points. The stationary points are 0, 0 here, 0, 0 and negative 4 over 3, that's 2 over 27. So we have 0, 0 and negative 4 over 3, that's 2 divided by 27. So this is what we need to sketch the curve. So very first we go to sketching. So this is how we're going to sketch. So we have y-axis is there. So we have the point 0, 0, 0, 0 is there. And then negative 2, 0, negative 2, negative 3. So we have another point here, negative 2, 0. That is the point, 0, 0 is here. And then we have negative 4 over 3. Negative 4 over 3 will be somewhere here between, because that will be negative 1 and that, so it will be between 0 and here. So we have negative 1, so it will be between somewhere here if we can sketch it. So it will be somewhere here between 0 and 2. So that will be then 32 divided by 27, again it will be somewhere here. So if I approximate that point, so this is the point, this is the point, negative 4 over 3, we're just sketching 32 divided by 27, it will be somewhere there. Then we have another one. I think those are the only points that you're going to use. Then it is always good to know these are nature. The nature will also help you to sketch, to know whether it will be a U or an N. So like 0, 0 is a minimum, 0, 0, this one is a minimum, this one is a minimum, and if it is a minimum, you should have an idea, it should look like that. And then this one is a maximum point, so if the maximum point, something like this, and this is what it is, so that curve will look like this. And then where we have 0, 0, because it is minimum, that will be a U like that. So that is the curve, and that is how you sketch the curve, by using the intercepts and the stationary points. Three ports A, B, and C are situated in such a way that port A is 140 kilometers on a compass bearing of north 65 degrees east from port B. Port C is 200 kilometers on a compass bearing of south 32 degrees east from A. A ship S is docked in the sea 86 kilometers on a bearing of 190 degrees from port B. Part A. Using a scale of 1 centimeters to represent 20 kilometers, draw a diagram to show the positions of ports A, B, and C and ship S. And then we have the other question down here. Part B. Using your diagram, find 1. The distance between the ship and port A. 2. The bearing of ship from port C. 3. The distance from B to C. Then 4. How far C is south of A. So after doing that, now we can construct these, and you're given the scale 1 centimeter to represent, so 1 centimeters to represent 20 kilometers. So we're going to start with the first one, that is port A is 140 kilometers on a bearing of north 65 degrees from B. So I'll start by drawing the north at B, indicating the north. When you're drawing the north, always ensure that the north is always at 90 degrees. So let me draw the north. Always ensure that is always 90 degrees. So this is what I mean. When you construct the north, always ensure that this angle here is 90 degrees. So if I measure that angle, you can see that angle is 90 degrees. So this will be point B. This will be point B at the center here. So you're supposed to, so from that point, A is north 65 degrees from B. So we shall measure 65 north 65 degrees. So this is how we're going to measure that. So we have place it like that, and then 65 degrees. You can place it like this. The best way to do this, because you measure the angle from the north. Place the protractor like that, and then this is from here we have 0, then 65 will be here. So you can mark 65 here. So 65 will be there. So using a straight line from that point like that, that is 65. You can confirm this angle should be 65 degrees. So that angle, I'm sorry, this angle here should be 65. That is the angle, and let me confirm, just to confirm that. So this angle, yes, it is indeed 65. So now A is north 65 degrees east from port B. So B is there, and that is 140 kilometers. A is 140 kilometers on a compass bearing of north. So we need to measure 140 using this scale. 140 using the scale will be 1 centimeter represent 20. So 140, you just divide by 20. These will have to measure 7. So I have to measure 7. So let me use a pair of compass here. Measure 7. So take 7 centimeters. So 7 centimeters is there. And then you mark it like that. So A will be here. Now you can see we have represented the first statement that A is 140, that is 7 centimeters. So A is 140 kilometers on a compass bearing of north. This is north 65 degrees east from port B. So we have illustrated that. Then port C is 200 kilometers on a compass bearing of south 32 degrees east from A. So from A, you're going to draw a compass again. Draw a compass that is a north, construct north at that point. You need to be very keen when you're constructing the north. Construct the north. When you're constructing the north, always ensure that this angle is always 90 degrees, just like that. And then you should pass there. So that is the north. Construct the north at A. So this angle is 90. Mine is 90. You can use a protractor to ensure that yours is 90. So from A, 32 south 32 degrees east. So which angle is that? That is compass bearing. So we're going to measure the angle that is you're going to measure is here. So this is how you're going to place your protractor. So like that. And then we're going to measure 32 degrees. 32 degrees from here. Let me see. I'm supposed to place it like that. Yes. So now I want to measure south 32 degrees east from A. South 32 degrees east from A. So you're going to measure it this way. So this is 10, 20, 32. So 32 will be somewhere there. 32 will be somewhere there. Let me mark it properly. So 32 will be, this is 30, that one will be somewhere there. So 32 is there. So this angle, so this is how you measure the angle. So from here, you're measuring 32 like this. So this is 0, 10, 32 is there. So you mark that like that. So this angle that is here, this angle is the one that is 32 degrees. 32 degrees. This is south. So that is now so we need to measure, that is a 200 kilometers. 200 kilometers using the scale 1 centimeter represent 20 kilometers. So that one will be 200 kilometers divided by 20. So we have to measure 10 centimeters there. 10 centimeters. So that is 10 centimeters. So this is 10 centimeters, that is equivalent to 200 kilometers, and this one was 140 kilometers. Now look at the position of C now from A. So C is on a compass bearing of south to the south 32 degrees. So look at how I measured 32 degrees. 32 degrees east to the east of this side. This is the east. This is the east. So that is how you're supposed to do it. Then the next one is a ship S is docked in the sea 86 kilometers on a bearing of 190 from port B. So 190 from port B. So 190 from port B. So we have this angle. We measure the true bearing from the north in a clockwise direction. So that is 180. That is 180. So we need to add 10 degrees here to get 190. So that is how we place it. So we are adding 10 degrees. So that we have 180 plus 10. That will give 190. So 10 degrees. Quite very small. 10 degrees. So we have 0. 10 degrees will be there. So 10 degrees will be there. So from this point, so this is so from here 10 degrees will be there. So draw a straight line, that is 10 degrees. So after that, the next thing you're going to do, we have that one is 86. So S is docked in the sea 86 kilometers on a bearing of 190. So 86 kilometers, we divide that one by 20. This will give 4.3 centimeters. So we measure 4.3 centimeters. That is a 4.3. So this is where we have the ship. That is the point where we have the ship. So you can see 190 degrees. That is, we measure it in clockwise direction from the north. Now I think we have illustrated everything, all the positions. So the position of S is there, B is there, A is there, and C is there. C is there. So the next thing that you need to do now is go to the questions. Let's go to the question. So find the distance between the ship and the port A. The ship and the port A. So you can join that using a straight line. Ship and the port A. So ship and the port A. So that is the distance. That is the distance. So let me join this one using a ruler. So we measure that distance between S and A. So let me place the ruler there. So that will give, that is around 10 point. Or you can use a pair of compass to do that. Any can work, but you place it here. That is 10.2. I'm getting 10.2 centimeters. So these will be 10.2 centimeters. Remember, you're supposed to give the answers in kilometers. So 10.2 centimeters, you multiply that by 20, since 1 centimeter represents 20 kilometers. And these will give... so 10.2 times 20, that will give 204 kilometers. 204 kilometers. Then the bearing of the ship from port C. Bearing of the ship from port C. Bearing of the ship from port C. So the first thing you're going to do is joining the... You're going to join bearing of the ship from port C. That join the place, the two places using a straight line. Then from there, you're going to draw north. So you're getting the bearing from which point? From port C, of the ship from C. So you're going to draw your north at C. Draw the north at C. So draw the north. So that is the north. So that is the north at C. And then the angle you're supposed to measure is this angle from this point all the way to this point. So you're giving the bearing, and you're supposed to give, this is the bearing of the ship from port C. So you have to measure the whole of that angle, the whole of this angle that is here. So from the north up to that line. So what you can do, you can get this angle, you can get the angle that is remaining, you can get the angle that is remaining. So this is, you measure this angle here, measure this angle from this point to this point. Then you take 360 because you want the whole of this angle. You're going to take 360, subtract this angle here. 360, subtract this angle. So this angle is 80. So 0, that is 85. So that angle is 85. So since this angle is 85, so this angle that is here is 85, and the bearing is the whole of this angle. So it will be 360 subtract 85. 360. So 360 subtract 85. 360 subtract 85. That will give 275. 275 degrees. Then the other question, part 3, the distance from B to C. Distance from B to C. So distance from B to C. B to C. Again, for that one, you can use a pair of compass to do that. B to C. Distance from B to C, that is point B. And then I stretch it up to where we have C, like that. So from B to C, that is giving 12.9 centimeters. 12.9 centimeters. So that is giving 12.9 centimeters. We convert that to kilometers by multiplying by the scale given. So 12.9 times 20, that will give 258 kilometers. Then how far C is south of A? That is part 4. How far C is south of A? How far C is south of A? So to do that, to get that, this is what you're going to do. You're going to extend this line. There's this line that is here. You're going to extend this straight line that is here. You're going to extend that line. And then look at this north. This north here. You're going to extend that one as well. The north straight. And wherever they meet, the two lines are meeting at this point. So this distance here shows how far C is south from A. So A is here. So this is a perpendicular distance between. Actually, the question is about the perpendicular distance between A and C. So this is the level where A is, and this is the level where C is. So measure this distance. This is what is going to give you the answer. So let me get that answer. So that is giving 8.5 centimeters. So 8.5 centimeters. So this is giving 8.5 centimeters. We multiply by 20 because of the scale of them given here. So 8.5 times 20, that will give 170 kilometers. Then the last question, the compass bearing of S from A. The compass bearing of S from A. Compass bearing of S from A. S from A. S from A. So already we have drawn the line joining S and A. So you're getting the compass bearing of S from A. So you're going to place our protractor here at A and measure this angle. So the angle that is required will be this angle here. This will give the compass bearing, and actually to the south. So we measure that angle. So we measure that angle. We measure that angle, and that angle gives it gives what? It gives so this is 10, 20. This is giving 45, around 45. Let me place it as giving around 45 degrees. So this angle here is 45. So this angle is 45. So now to give the compass bearing of S from A, you can see S is to the south. So you're going to write south. Then the angle between the angle that you're measuring, this angle here, S is to the south of A, then 45 degrees to the west. This is the west. 45 degrees to the west. 45 degrees to the west. 45 degrees to the west. So that is how you're supposed to solve that question. Given the matrix A is equals to 4, 15, -1, -4, find A squared. Part B, two businessmen, Thomas and Stephen, bought radios and juice blenders at X shillings per radio and Y shillings per juice blender. Thomas paid a total of 60,000 for 15 radios and 20 juice blenders, while Stephen paid a total of 64,000 for 14 radios and 24 juice blenders. 1. Form a matrix equation to represent this information. And 2. Use the matrix method to find the cost of 1 radio and 1 juice blender. And then part C. Thomas sold all his radios and juice blenders at a profit of 20% per radio and 25% per juice blender. Stephen sold all his radios and juice blenders at a profit of 25% per radio and 20% per juice blender. calculate the profit that each businessman made. So those are the questions. Let's go to the first part. First part, you're given the matrix A, you're supposed to get A squared. So that just simply means it is A matrix A multiplied by itself, that is A squared. So we can work out this one. So A squared means 4, 15, negative 1, negative 4, multiply by itself, that is 4, 15, negative 1, negative 4, that is A squared. So row 1, column 1, we have 4 times 4. This is 4 times 4 plus negative 1 times 15, that is negative 15. Let me just write the whole of these. So negative 1 times 15. Row 1, column 2, 4 times negative 1 plus negative 1 times negative 4. Like that. And then row 2, column 1, 4 times row 2, column 1, 4 times 15 times negative, these are plus negative 4 times 15 row 2, column 2, 15 times negative 1 plus negative 4 times negative 4. So that is what you're supposed to get. So this will be, the first one will be 16 minus 15, that will be 1. Then this will be negative 4 plus 4, which will be 0. Then this is a 60, subtract 60, that will be 0. Then this is negative 15 plus 16, that will give 1. So that is what you're supposed to get for that part. Part 2. Two businessmen, Thomas and Stephen, bought radios and juice blenders at X shillings per radio and Y shillings per juice blender. So Thomas paid a total of 60,000 for 15 radios. So 15 radios, the cost of one radio is X. So that will be 15X, cost of all the radios. And then 20 juice blenders. Juice blenders, one cost is Y shillings. So that will be 20Y is equals to, that is a total of 60,000. Then Stephen bought 14 radios, that will be 14X, the cost of all the radios. Then 24 juice blenders, each blender is Y shillings, so that will be 24Y is equals to total of 64,000. So those are the two equations. Now you can, when I look at them, it is possible to simplify each one of them. Like the first one, you can divide equation 1, you can divide it by 5, each term by 5, and that one will give 3x plus 4y is equals to 12,000. So that is equation 1 simple. Equation 2, you can divide everything by 2, and you can get 7x plus 12y is equals to 32,000. So you can simplify them like that. So that is equation 2. So the question is form a matrix equation. So you've not formed a matrix equation. Now forming the matrix equation means you extract the coefficients of x and y. So these are 3, 7. Then this is a positive 4, 12, positive 12. And then you multiply by x and y. You have x and y, the cost of radio and juice blender is equals to 12,000, 32,000. So this is the matrix form, that equation. That is the first part. Now the second part, use the matrix method to find the cost of one radio and one juice blender. So you simply require to solve the matrix that you formed in this part above. So the first thing is to get the determinant. You have to get the determinant of this matrix here. And the determinant of this matrix 3, 7, 4, 12 will be, so determinant will be 3 times 12 subtract 4 times 7. So this will be 36 subtract 28, and this will be 8. So the determinant is 8. After getting the determinant, you should get the inverse of that matrix. And remember, we are getting the inverse of this matrix 3, 7, 4, 12. So its determinant is there. So the inverse, you get the inverse by getting 1 divided by the determinant, and then these terms, you know how we interchange these terms, eh? So here you'll get 12 negative 4, 12 negative 4, negative 7, 3, like that. So I want you to check what is happening here. So you can see the elements in this diagonal, how they are. Let me use it. So you can see the elements in this diagonal 3, 12, they're interchanging 12, 3, and then the elements in the other diagonal 4, 7, they're changing the signs. That is how you get the inverse. So after getting that, you pre-multiply both sides of this matrix by this inverse. So you multiply, you have 3, 7, 4, 12, like that. X, Y is equals to, you pre-multiply, means this inverse should come before. So you should bring that on here again. So 1 over 8 is the inverse, 12 negative 7, negative 4, 3. And this is 12,000, 32,000, like that. So this is the inverse. This is the inverse. Now it comes to multiplying. When you multiply this side very well, you always get an identity matrix 1, 0, 0, 1. You'll get an identity matrix when you multiply this side. 1 over 8 multiply by this, you always give an identity matrix which has no effect. The identity matrix will not have any effect when it comes to multiplying x and y. So for this part, let us multiply this part. So this one you shall have 1 over 8. And then this one, row 1, column 1. So this will give 12 times 12,000. Then plus, this will be negative 4 times 32,000. That is row 1, column 1, and then row 2, and the first, this column, row 2 will get negative 7 times 12,000 plus 3 times 32,000, like that. So when you work out these, the left hand side, for this side, the identity matrix multiplied by x and y, that will give xy. Doesn't change anything. Then for this part, you remain with 1 over 8. Then when you multiply, when you add these 12 times 12,000 plus negative 4 plus times 32,000, that will give 16,000. And then the bottom, negative 7 times 12,000 plus 3 times 32,000, that will give 12,000. So xy therefore is equals to, multiply each term, 1 over 8 times 16,000, that will give 2,000. And then 1 over 8 times this 12,000, that will give 1,500. So therefore x is equals to 2,000 and y is equals to 1,500. 1,500. And you know, x is the cost of radio. One radio is therefore 2,000. One juice blender is 1,500. So we're through with that part. Now we can proceed to the next part. Thomas sold all his radios and juice blenders as 20% per radio and 25% per juice blender. So let us get the profit made by Thomas. So 20% for each radio. So the profit will be 20 over 100 times the cost of one radio is 2,000. How many radios did he buy? We go to the question. The radios are 15. So we multiply that one by 15 like that. That is the profit for the radios. Then juice blenders profit is 25%. So that is 25 over 100 times the cost of juice blender. That is 1,500. Then how many are they? They were 20. There were 20 juice blenders. So you can go to the question and confirm there are 20 in part B. So that will give the profit made by Thomas. So we can add up. So 20% times 2,000 times 15, that will give 6,000. 25% times 1,500 times 20, that will give 75. So the total will give 13,500. That is for Thomas. Then Stephen. So for Stephen, he sold all the radios and juice blenders at a profit of 25 per radio, 25% per radio. So 25 over 100 times radio cost is 2,000 times how many did he buy? 14. Bought 14. So you could go and confirm part B. Stephen paid 14 radios and 24 juice blenders. Then we add for juice blenders, profit was 20%. So 20%, 20 over 100. The cost of one juice blender is 1,500 and they were 24. Bought 24 in total. So we can multiply out and add. So 25% times 2,000 times 14, that will give 7,000 plus 20% times 1,500 times 24, that will give 7,200. And the total here will give 14,200. So the question is calculate the profit that each got. So Thomas got 13,500, then Stephen got 14,200. The following table shows the marks scored in a mathematics test by 80 Form 2 students. So the marks are there. Part A of the question, complete the frequency distribution table for the data. Then part B, from frequency distribution table, find the mean. And then the next question, part C, on the grid provided, represent the above data using a histogram. 3 marks. And then part D, use the above histogram to determine the number of students who scored above 68.5. So let's go to the first part where we're supposed to complete the distribution table for the data. Now we are going to have the tally. We are going to indicate the tally here and the frequency there. So we count. So the first class 10 to 19. So any value that is from 10 to 19, can identify that. 10 to 19. 10 to 19, identify that, so there's one there. 10 to 19, let me check whether we have another one. 10 to 19, so I've identified 15. You need to be very keen when you are checking these numbers so that you don't leave any. Need to be very careful. Very careful. Sometimes you may fail to see them. They're there. So when I look at the whole of these numbers here, the marks that are between 10 to 19 are 2. They are 2. So 2. The tally for that is just 2 strokes like that. 20 to 29. 20 to 29. 20 to 29. So any value that is between 20 to 29, we identify that. So we have one there. 20 to 29. Here's another one there. and this one. So I can see there are 3. So there are 3. Sorry, there are 3. So there are 3. So 3 strokes for that. 30 to 39. 30 to 39. You have 1 there. 30 to 39, another one there. Another one there. 30 to 39, there's another one there. And another one there. So I don't see another one. So there are 1, 2, 3, 4. There are 5. So 30 to 39, there are 5. So 5 strokes. So 4, and then you cross 1 there. That is how you get tally for that. 40 to 49. 40 to 49. 40 to 49. 1 is there. Another one is there. Another one is there. Anything that is between 40 to 49. Anything that is between 40 to 49. Anything that is 40 to 49, that is what I'm putting a circle. There are many. 40 to 49. 40 to 49. There is 46. There is a 44. There is a 49 there. There is 47. There is 46. 44. 48. 44. Like that. So just check if I've left 80. 40 to 49. So let me count and see. You have to verify. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. And there are 23. There are many. So the tally for these, you have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That is 20. Then 3 strokes. It is 23. Then 50 to 54. Anything that is between 50 to 54. 50 to 54. This one there. Another one there. 50 to 54. Another one there. 50 to 54. This one there. 52. 51, 51, 53, 52. Me count. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10. There are 10. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Then 55 to 59. 55 to 59. 55 is there. 59, 58. 55 again. 56, 56, 55, 58. There is also 59, 59, 56, 56, 58, 55, 57, 58, 57. Check whether I've left any. Me count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. There are 18. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Those are 15. Then 18. 60 to 69, 60 to 69, so 60 to 69, 60 to 69, 63, 63, there's 64, 60, 60, 69 is there, 68, 61, 'Verify these for 55 to 59, 55 to 59. They can verify that. I don't know whether I made it. The left of figure there, 58. Let me confirm 58, 59. 55 to 59. I think it's okay. It is 18. It's okay. It's okay. So I'm 60 to 69. 60 to 69. Another one there. 61. There's also another one there. Check whether I've left any. $60 to $69. $60 to $69. Need to be very keen, because once you leave one, you can mess the whole thing. Oh, it is here. Can count them now. 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9. So the tally 1, 2, 3, 4, 5, 1, 2, 3, 4. 70 to 79. 70 to 79. They are now reducing. We have 1. We have 2. We have 3. We have 4. We have 5. We have 6. There are 6. So those ones are 6. 1, 2, 3, 4, 5, then 1. Then 80 to 89. 80 to 89, let me check. They are now reducing. Check what you don't have. So there is 1, 84, and then there is 81. So there are only 2 for that. So the tally for that is like that. Then 90 to 99. 90 to 99. There is 1 here, 90. And there could be another one. There could be another one. There's 90. I've seen 90. Trying to check the one that I've not checked, because only one is remaining. Was 98. So there are 2. There are also 2 like that. So that is how you're supposed to complete the frequency distribution, by making sure you put the frequency and the tally, and you always confirm to ensure that you are accurate. Now from there, the other question is from the frequency distribution, find the mean. So how do you find the mean? You need to understand that first. So mean, which is x bar, is obtained by the summation of fx divided by the summation of frequency. So summation of fx, we need to get the x column, and x column is the midpoint. We need to get the x column, and that is the midpoint of all these classes. Like for the first one, 10 to 19, you simply get the midpoint by taking 10 plus 19, then divide by 2, that will be 14.5. Then the other one, 20 plus 29 divided by 2, that will give 24.5. 30 plus 39 divided by 2, that will give 34.5. 40 plus 49 divided by 2, that will give 44.5. Then 50 plus 54, that will give plus, this will give 52, the midpoint. 55 plus 59 divided by 2, you get 57. Then 60 plus, that will give plus 69 divided by 2, 64.5. And then 70 plus 79, that will give 74.5. 80 plus 89 divided by 2, that will give 84.5. 90 plus 99 divided by 2, 94.5. So that is the midpoint. So the next thing you need to get now is that product fx. Just take frequency multiply by the midpoint. So the first one is 2 times 14.5. We do this one very fast. So this one you get 29, is black here. So you have 29. Then the other one is 73.5, 172.5. And the one is 1023.5. And the one is 520. 1026, 580.5, 447, 169, and you get 189. After you've done that, you need the summation of fx. You add everything, 29 plus 73.5 plus 172.5 plus 1023.5 plus 520.5, add everything, and this will give 4230. Then we go to the frequency. The frequency already you know, this one should give you 2 plus 3 plus 5 plus 23 plus 10 plus 18 plus 9 plus 6 plus 2 plus 2. This one should give 80. That is summation of frequency. Now with that, you can get now the mean, since you just need to get the summation of fx, which is 4230 divided by 80. And this one, when you divide it, you'll get 52.875. That is how you get the mean. We go to the next one. The next part, part C, on the grid provided, represent the above data using a histogram, and you're supposed to use the frequency, density, and the max. So you can see we plot the upper class boundary, and then on the x-axis and the y-axis frequency density. So we need to get that from these, to insert that in this table. Need to insert it. So we need to insert it. So let me insert it. So frequency density. How do we get frequency? Because that is where we're supposed to begin. So there's a formula that we use. Frequency density is given by the frequency divided by the class width. Frequency divided by the class width. So we need to get the class width first. The class width. We get the class width. And the class width, you get it by taking the upper class boundary, subtract the lower class boundary. For example, in the first class, you get 19.5. That is the upper class boundary minus the lower class boundary, which is 9.5. That one will give you class size of 10, like that. Then you go to the next class. The next class will be 29.5, subtract the lower class boundary, which is 19.5. That again will give you 10. So that is how you work it out. So the other one again will give, to still give 10. Even this one is 10. with 50 to 54. For this one, you need to be careful, not uniform. 54.5 minus 49.5, that class size will be 5. And also for this one, we have 59.5, subtract 54.5, again that one will be 5. Then 69.5, this will be 10. For the other class, again, that will be 10. And then this one will be 10 as well, and this one will be 10. So that is a class width. So now let's get the frequency density. So frequency density, which we have noted, we get it by getting the frequency divided by the class width. So like the first one, frequency is 2. I'll just illustrate that one using the first class. The first one, the frequency is 2, the first class. Then the frequency density is, or the class size, the class width, I'm sorry. So frequency density is equals to frequency, which is 2 for the first class, 2 divided by the class width, which is 10. So that will give 0.2. So we do that for all the others. So the other one will be 3 divided by 10, 0.3. The other one is 5 divided by 10, 0.5. And then the other one will be 23 divided by 10. This will be 2.3. Then we have 10 divided by 5. That will be 2. Then 18 divided by 5. This will be 3.6. 9 divided by 10, 0.9. 6 divided by 10, 0.6. 2 divided by 10, 0.2. Then 2 divided by 10, 0.2. Now that one will help us to plot because we need the frequency density, like for the first one. Then the class boundaries, they are already given them. So we use the upper class boundary. So I'll put them here. Upper class boundary for this one will be 19.5. This one will be 29.5. This one will be 39.5. This one 49.5. This will be 54.5, 59.5, 69.5, 79.5, 89.5, 99.5. So when you are drawing the histogram, we use the frequency density against the upper class boundary. So like the first class, 19, the class will go up to 19.5. So from 9.5 to 19.5. 19.5 will be here. So that one, the first class will be frequency density is 0.2. So you should understand the size of one small square. So this is size of one small square will be 1 divided by 5, that is 0.2. So this is how we're supposed to plot it. So it's supposed to be somewhere there. So 19.5 is there. So that is the first class. The second class begins from, it goes up to 29.5. 29.5. The frequency density is 0.3. 0.3. That is slightly higher, just slightly higher than the other one, like that. Supposed to be up to that point. So it's supposed to be up to that point. And then the other one is 0.5. It goes up to 39.5. 0.5. 0.5. It goes up to 39.5. So that one 0.2.4.5 will be somewhere there. 39.5 will be there. So that is how you get it. So I can indicate these points here. These are points, very important. Can indicate the points there. So this one is 19.5. This is 39.5. This is 59.5. This is 79.5 and this is 99.5. So the next class goes up to 49.5, 2.3, 49.5, 2.3. So 2.3 will be somewhere there. Goes up to 49.5. Like that. And then the other one goes up to 54.5, 2. Frequency density is 2, 54.5, 50. Is it 54.5? Yes, it is 54.5. So you need to understand the size of one small square in the x-axis. So this is one small square will be, because 1 centimeter represents 10, so one small square will represent 5. To represent 5. So from 49.5 to 54. Is it 5? This is 10 divided by 2 be 2. One small square will represent 2. Sorry, 2 be 2. So this one will go 54.5 will be at the middle here. Will be somewhere here in the middle. And that one, the frequency density is 2. So it will be somewhere here. Let me draw this one properly. To be there. That will be place up to 54.5. It is up to this point. So this is what you should get. Then the next one is 59.5, 59.5, 3.6, 59.5, 59.5. So that will be 3.6. To 3.6 will be, so 15.5 is moving up like that. Then 3.24 and 6 will be there. So it will be like that. Then the other one is 69.5, 0.9, 69.5, 0.9. So 0.9, so 0.8, go up to that point. Up to that point. And then the other one 79.5, 0.6, 79.5, 0.6. 0.6 will be 0.246 will be there. That point. Then 89.5, 0.2, 89.5, 0.2, 0.2 will be there. The other one is 99.5, 99.5, 0.2 again. So these will be uniform. To be like that. So after I've done that, we can shade this one so that it can be seen properly. So the first one is there. Then the second one is there, the third one. So those are the bars. So these are the bars. So that is the histogram that you need to graph. Now after you've done that, part D, use the above histogram to determine the number of students who scored above 68.5. So the first thing is to identify 68.5. You can see it is somewhere here. 68.5 is somewhere around here. And this is how we're going to get the number of students. Remember, the number of students will be represented by frequency. So according to this formula, frequency density is equals to frequency divided by the class width. So frequency, to get the frequency which represents the number of students, we are going to take frequency density multiplied by the class width. So this is what you're going to use. And since we want the number that is greater, those students who scored above 68.5. So look at the x-axis, that is where you have marks. So we are going to start from the highest, that is from 99. I'd like you to look at this class from 99.5, from 79.5 to 99.5. How many students in that bar scored? So to get the frequency there, we are going to take the frequency density of that class, which is 0.2. That class that begins from 79.5 to 99.5. So we take the frequency density, which is 0.2, then we multiply by the class width. The class width there is 10. The class width there is not even 10, because it runs all the way. This 79.5 to 99.5. We can get that difference. That would be 9.5, 79.5. So that will give 20. So that is the simpler way. You can actually do it from 89.5 to 99.5. You can break it into two, but I have taken it because it is uniform. From 79.5 to 99.5, the frequency density is uniform. So the class width there is 20. So that will give the number of students there. And then the next one is from 79. Now I want you to check this, from 69.5 to 79.5. How many students are there? So from this point, from 69.5 to 79.5. So we add the number of students who are there. So 69.5 to 79.5. The frequency density there was 0.2.4. It was 0.6. The frequency density was 0.6 for that class. And then the class width. The class width is just subtract 79.5, subtract 69.5, it is 10. So the number of students there will be given by frequency density, that is from these 69.5 to 79.5. The frequency density, even when you go to the table, you find it is 0.6. You can even read it from the graph directly, because we feel that 0.246. Then multiply by the class width. Then lastly, we know we have now worked up to this point, 69.5, but we need 68.5. So we need the remaining is now from 68.5 to 69.5. So we need to get that range. So that is what is remaining now, from 68.5 to 69.5. That is what we need to know, the number of students. So that one falls in this class, where the frequency density is 0.2, 0.4, 0.6, 0.7, 0.8. Is it 0.8 or 0.9? It is 0.9. 0.9. Look at that class 60 to 69, that is the class. So the frequency density there is here, it is 0.9. So frequency density of that class is 0.9 times the class width. Now be careful here. The class width, we want it is from 68.5, because we want 68 and above, from 68.5 to 79.5. So just get the class width there. Take 69.5, subtract 68.5, and that will give you 1. That will give you 1. So now the number of students will be given by, so here we are going to get, so we're going to get 4 here, plus here we are going to get 6, and then here we are going to get 0.9. So when you add these, you're going to get 10.9 students, and since these are students, you're going to round this one downwards to have 10 students only. So that is how you're supposed to solve that question. The line L1, whose equation is 2x plus hy is equals to k, cast the x-axis at x is equals to 3 and cast the y-axis at y is equals to 6. Find, part A, the values of the constants h and k, B, the gradient of the line L1, and then part C, the equation of line L2, which is perpendicular to L1 and passes through the point -2, -5, giving your answer in the double intercept form. And then part D of the question, the coordinates of the point of intersection of the two lines. So those are the questions. Let's go to the first part. So for the first part, you're given the equation of line 1, whose equation is given. And then this is the most important point. It cuts the x-axis at x is equals to 3. So therefore, if it cuts the x-axis at x is equals to 3, the coordinates of that point where it cuts the x-axis will be 3, 0. Remember, it cuts the x-axis when the y coordinate is 0. So the point will be 3, 0. And then it cuts the y-axis at y is equals to 6. So where it cuts the y-axis, the value of x is equals to 0, then y will be 6. So that is very important. So in order to get the values of h and k, we simply need to take 2x plus hy is equals to k and substitute, because it has the x-axis at 3, 0, this point 3, 0. So x is 0, substitute it there. When y, x is 3, not 0. When y is 0, so y is 0. Just substitute that, you get k. And for this one, you notice you get k to be 6. Then for the next one, because we need to get h, we are going to use where it casts the y-axis. Again, you take the equation that is 2x plus hy is equals to k. It cuts the y-axis at this point, 0, 6. So substitute where we have x, that is 0. So this one will be 2, 0, plus where we have y, you can substitute that one with 6. So this one will be h, 6 is equals to k. We have already obtained k in the first part, which is 6. So this will give 6h. This equation will give 6h is equals to 6 and h is equals to 1. So we have found the values of h and k. K is 6, h is 1. Then after doing that, we can get the gradient of line 1. Remember, this is the line 1, that is line 1. Now after getting the values of h and k, we can substitute them in that equation so that we have 2x plus h is 1, so 1 times y, that will be y, is equals to k is 6. So to get the gradient, you can organize this equation in the form y is equals to mx plus c, so that it becomes y is equals to negative 2x plus 6. And therefore, the gradient will be the coefficient of x. So the gradient of that line will be negative 2. We go to the next part, part C. equation of L2, which is perpendicular to L1 and passes through -2, -5, giving the answer in double intercept form. So the equation of L2, which is perpendicular to L1. Now, one important thing that is going to help you is the fact that if you have two lines that are perpendicular, already we have the gradient. We can call this gradient 1 of line 1. This is the gradient of line 1 as -2. Now for line 2, because it is perpendicular, gradient will be, you remember this concept, when two lines are perpendicular, the product of the gradient should give -1. So we have M1 is, so this is M1, M2. The product of their gradient, M1 times M2, should give us -1. So we have the gradient of line 1 as M1, which is -2. So what will be the gradient of L2 using this fact? This will be 1/2. So that when you multiply the gradient of line 2 times the gradient of line 1, you should get -1. So we have now the gradient of line 2, which is 1/2, and it passes through -2, -5. So now with these two, we can get the equation of L2. We have the gradient as 1/2, and we have the point. So we can get the equation. So to get the equation, I will just introduce another general point on the same line, xy, and this is how you get the equation. So change, the gradient is changed in y, which is y subtract -5, which will be y plus 5, divided by change in x subtract -2, which will be x plus 2, is equals to 1/2. When you cross multiply here, you will get this one as 2y plus 10 is equals to x plus 2. So we want to give this equation in double intercept form. And just to remind you that the equation in double intercept form should be like this: x divided by a plus y divided by b is equals to 1. So this is how you should leave the answer in double intercept form. So this is the format that we need. So we need to reorganize this equation so that we organize it in this form, double intercept form. So this is what you're going to do. You're going to bring a -x to the left hand side. We get -x, then plus 2y, plus 2y, and then this one is equals to, now we can take 10 to the other side. This will be -8. We've seen what I've done. So I've taken x to the left hand side, then +10 to the right hand side. So 2 subtract 10. So that is what I've done. So I've taken this one there and this one here. So from there, you can divide all through every term by negative, which will give x subtract 2y is equals to +8. Each term by negative. And then since you want 1 here, you divide everything by, you divide this one by 8, this one by 8, and this one by 8. So the equation in double intercept form will therefore be x over 8 subtract y divided by 4 is equals to 1. So that is the equation in double intercept form. The next question: the coordinates of the point of intersection of the two lines. The coordinates of the point of intersection of the two lines. So we have line 1, we get the equation. The equation of line 1, we are going to use this one. So I'll use this one. 2x plus y is equals to 6. 2x plus y is equals to 6. Then line 2, the equation of line 2, we'll use this one. There's a reason why I'm picking the equation in this form, because for you to get the point of intersection of two lines, you have to solve the two equations simultaneously. When you take the two equations, can see both equations are having x and y. So when you solve them simultaneously, you'll get the value of x and y, and that will give the x coordinate and the y coordinate, and that will be the point of intersection. So I'll pick this particular equation here, the way it is. So this is negative x plus 2y is equals to negative 8, like that. So all the same, you can multiply this one by negative, each term by negative, so that you have x negative 2y is equals to 8. So this is equation 1, this one is equation 2. I've simply multiplied to get rid of this negative. I've just multiplied each term by negative in order to get that equation. So you're going to solve these two simultaneously. Now you have 2x plus y is equals to 6 and x minus 2y is equals to 8. So you can use any suitable method. I'll use elimination. I'll multiply this one by 2 to eliminate x, so that I have 2x plus y is equals to 6. The second equation, multiply everything by 2. You get 2x, subtract 4y is equals to 16. Then the x's are the same. You can subtract y, subtract negative y. That will be 5y. That will be 5y is equals to, this is a 6 subtract 16, that will be negative 10. So y becomes what? Negative 2. So once you get y as negative 2, you can use any equation to substitute. So I'll use this one. I'll use this equation to substitute. So x minus 2y is equals to 8. So when y is equals to negative 2, x, this will be x plus 4. When you substitute 2y, substitute y with negative 2 is equals to 8. So x is equals to 4. So therefore you have the value of x and y. So now the point of intersection, you get it by x is 4, so that will be 4, and y is negative 2, like that. A quadrilateral PQRS has vertices at P 6, negative 2, Q 4, negative 6, R 4, negative 4, and S 2, negative 2. Part A of the question: on the grid provided, draw the quadrilateral PQRS and its image P1, Q1, R1, S1 under the enlargement scale factor -1/2 and center 0, 0. So this is the first part. So let us, the first thing you're going to do is to plot that PQRS. So we plot that very first. PQRS, you start with P. So I'll draw the X and the Y axis. The X and the Y axis. Let me draw the X and the Y axis. So there you go, the X and the Y axis. So this is the X axis and this is the Y axis. This is the Y axis. So this is 0. This is 1, 2, 3, 4, 5, 6. This is a -1, -2, -3, -4, -5, -6, -1, -2, -3, -4, -5, -6. We have 1, 2, 3, 4, 5, 6. So the first one is P 6, -2. P is 6, -2. So 6 and -2 is here. So this is where we have P. The next one is Q 4, -6. Q is 4, -6. So we have 4, -6 is here. Q 4, -6. The next one is R 4, -4. R is 4, -4. 4, -4 is here. So this is R 4, -4. And then the last one is S 2, -2. 2, -2. So 2 is here, and then -2 is there. That is S. So 2, -2. Now we have all the points. So you have P. P is there. We have Q is there. R is here. and S is here. So this is where we have S. So we can now join them. We can join those points. So we start with P, we join from P to Q. You should follow that order. Then from Q to R, then from R to S. R to S, then from S now you can join, or to S to P, like that. So there is the quadrilateral. So the first question, we are supposed to give the image P1, Q1, R1, S1 under the enlargement scale factor -1/2 about the origin. So the center is the origin, scale factor is -1/2. So scale factor, so the first thing you're going to do, because the center is the origin, we're going to draw straight lines. You're going to draw straight lines, and from each of those points, we start with P. So you join P to the center of enlargement using a straight line, like that, using a straight line like that. Imagine it properly. So from P, using a straight line, you join that straight line. Now to get the image of P, you've joined P to the center of enlargement using a straight line. The scale factor of enlargement is -1/2. So what you're going to do, the easiest way to do, is to count the number of squares. From P to the origin, how many squares are these? This is 1 square, 2, 3, 4, 5, 6. There are 6 squares. And the enlargement, the enlargement is -1/2. So if you have 6 squares, 1 from P to the origin, so from this point P to the origin, so 1, 2, 3, 4, 5, 6, there are 6. And since the enlargement factor is -1/2, we are going to divide that one by 2. What is half of the 6 squares? That is 3 squares. So from the origin, we are going to count 3 squares, 1 along that straight line, 1, 2, 3. So you're going to have the image of P here. So this is B. So this point will be P1. Now you can see from this point, from P to the origin, there are 6 squares. 1, 2, 3, 4, 5, 6. There are 6 squares. So because we're enlarging by 1/2, we count half of 6. So you're going to count 3 squares from the origin. So from the origin, you have 1 square, 2 squares, 3 squares. So that is where we have P'. Then we do the same for Q. We do the same thing for Q. So Q, you join Q to the center of enlargement. Join it to the center of enlargement like that. Join it to the center of enlargement. Then the same way, you count the number of squares that are there between Q and the origin, the center of enlargement. So this is 1. You have 2, 3, 4, 5, 6. There are 6. So enlarging by 1/2. So from the origin, you're going to count 3 squares. So 1 along that straight line. 1, 2, 3, like that. So you count again. So you have 3 squares. So 1, that is 1 square, 2, and then the third one will be there. Hope you can see how I'm counting. So from the center here, so up to this point, that is 1 square. Up to this is 2 squares. Then this one is the third one. The third one will be there because it is 1/2 of 6. So from Q on Q again, so 1 square, 2, 3, 4, 5, 6. So from the origin, you count 3. 1, 2, this is, I'm sorry. So this is from here. 1, you're counting from 0. That is 1, 2, and 3. So this is where you're going to have Q1. So Q1 will be there. We do the same for R. Join R to the center of enlargement. From point R, how many squares? 1, 2, 3, 4. So now we count 1/2 of 4 squares. There are 2 squares. So from the origin here, you have 1, 2. So this is where we are going to have R. That is where we are going to have R. This is R prime or R1. So R1 will be here. So the next one is after R we have S. Now you notice that R and S are on the same straight line. They are on the same straight line. So what it means, when I join S to the origin, it will be the same line as the line that I used when joining R to the origin. So the same line, but now the distance will change, because now from S to the origin, how many squares are these? They're just 2. 1, 2. From this point to this point, they're just 2 squares. So you have 1, 2. So half of the 2 squares will be 1. So from the origin, just count 1 square. So this is what we're going to have S. So S will be here. S prime will be there. So from that, now we can join the points. So P1, Q1, P1 is there. Then 2 R1, P1, Q1, then 2 R1, then from R to S. When you join that one like that. So let me use the different colors so that you can see it. So we have P1 to Q1 is there, then to R1, then to S, and then we have, that will be the quadrilateral will be there. So that is a quadrilateral, P1, Q1, R1, S1. So the first part, we're done with the first part. Now the next thing, that is the next question, is that part B. P2, Q2, R2, S2 is the image of P1, Q1, R1 under negative quarter turn about the origin. Negative quarter turn about the origin. On the same grid, draw the quadrilateral P2, Q2, R2, S2. So the image that we have just obtained, we are supposed now to transform that under negative quarter turn about the origin. So P1, Q1, negative quarter turn about the origin. So the same thing, we are going to start by joining the points P1 to the origin. That is the center of that rotation. Then from there, we measure the angle, negative quarter turn. We're going to measure negative 90 degrees. And negative 90 degrees, we shall measure that one in a clockwise direction. So take a protractor. This is how you're going to measure that. So after joining P1 to the origin, this is how you place your protractor. So you place it like this. So along that straight line, place it like that. And then since it is negative 90 degrees, you're going to measure that angle in a clockwise direction. So clockwise direction is this way. So when you're placing it on that straight line, the center part of the protractor is there. So, and it is at the origin. So you measure the angle from this point, when that is clockwise, negative 90 degrees, you measure it in clockwise direction. So you're going to have 90 there. So from this point, 90 will be there. So that is how you're going to draw a straight line. So let me mark that point. So this point here, this is how we shall have, that is how we shall have 90. So from this point, yes, that is 90 degrees. Then now, to get, you can see now this angle is 90. So take this distance from P1 to the origin. P1 to the origin, how many squares are these? 1, 2, 3. There are 3 squares. So you're going to count from the origin again. Should be equidistance. So this is 1, 2, 3. So the image of P1 will be here. So here we shall have P2. We shall have P2 there. So P2 will be here. That distance must be the same. So from P1 to the origin, so how many squares are these? This is 1, 2, 3. So the same number of squares, 1, 2, 3 from the origin. We do the same for Q. So you join Q1 to the origin. It is already done. So we did that. Then from there, place your protractor, and this is how you place it. So like that. So measuring 90 degrees. So this will be, so from here, you have 90 degrees will be there. So we're measuring from this direction like that. So 90 degrees will be here. So we mark 90. So 90 degrees, so you're going to have 90 degrees. So we join that using a straight line. Then from there, you count the distance or the number of squares. You count the you can measure that distance or count the squares from Q1 to the origin. So this is from Q1, this is a 1, this is a 2, there are 3 squares. So the same thing from the origin, this is a 1 square, 2 squares, so 3. So this is where we have Q2. Q2 will be there. So that is where we should have Q2. Do the same for R prime. So R prime is here, R prime is there. So join R prime to the center. It is done there. Stick your protractor, and then we place it along that straight line like that. So measuring 90 degrees, I can see I use 90. So measuring the angle from this point going this way, so 90 will be there. It will be there. So let me mark. So 90. So that is where you should have 90 degrees. So join. So from the center, you join in a straight line like that. So now you measure this distance. You measure this distance from R prime to the origin. Measure that distance. You can see how many squares are these. These are 1, 2 squares. Then from the origin along that line, 1, 2. So this is where we shall have R2. So R2 will be there. So R2 will be there. Then since S is along the same line, look at where S is. So S is here along the same line. So we want to give the image of this. So you join it to the center. It is there. We have measured the angle 90 degrees along this line. So the distance from S1 to the origin, that is 1 square. So from the origin, you just measure that is 1 square. So S should be there. So S2 will be there. S2 will be there. I think we have given everything now. We can join. We can join the points. So P1, Q1. So P1 to Q1. Then Q1 to R1 is there. Then from R1 to S1 is there. Then you join now this point. So there we have the quadrilateral and rotation negative quarter turn about the origin. The next one is part C. P1, P3, Q3, R3, S3 is the image of P2, Q2, R2, S2 under a reflection in the line x plus y is equals to 0. X plus y is equals to 0. Draw the quadrilateral P3, Q3, R3, S3. So now the image that we've just obtained, which is the R2, S2, that one is the image of P2 so the image that we've just obtained, that is P2, Q2, R2 should undergo a reflection in the line of x plus y is equals to 0 in order to give P3, Q3, R3, S3. So one thing that you're supposed to understand, that this kind of, the easiest way, this kind of reflection, y x plus y is equals to 0, it is the same with y is equals to, this will be negative x. And under this reflection, if you have an object point AB that is transformed into negative b, negative a, simply the coordinates interchange and they change the signs. That is under this reflection, y is equals to negative x or x plus y is equals to 0. So in short, the easiest way you're supposed to do this is by simply identifying the coordinates of, let's say, we'll do this one. This is a P2. So P2. So for P2, this is 1, 3. So that one, under this reflection, it will become negative 3, negative 1. So we said under this reflection, y is equals to negative x. The point, the coordinates, that is the x and the y coordinates, interchange and they change the sign. Then for Q2 is 3, 2. So that one, Q3, will therefore be negative 2, negative 3. Then R2 R2 is a 2, 2. So the image will be -2, -2. And then S2 is 1, 1, 1. So S3 will be -1, -1. It's as simple as that. Then you can plot these. So we start with P3, -3, -1. So -3, -1. So -3, -1 be there. That is P3. Then Q3, -2, -3. -2, this is Q3 is there. Then R3, -2, -2. And S3, -1, -1. So the points are here. So P3, -3, -1. And then we have Q3. Q3 is here, -2, -3. And R3 is here, -2, -2. And S3, -1, -1. So we can join those points. You can join them. So P1 to P3 to Q3, then to R3, then to S3, and then you complete it like that. So that is the easiest way to do it, by just understanding that these reflection x plus y is equals to 0 is the same as y is equals to -x, and that line, alternatively you could have done that line, and the line y is equals to -x is this line. Already it is there. It's this line that passes through the center of the axis. This is the line. That is the line. So this one is the line of reflection, and that line is y is equals to -x. You can draw that line and you'll see that these being the object and the image, they are directly opposite each other alongside that line of reflection. Now after doing that, now we can answer the last question. State the pairs of quadrilateral that are directly congruent. So what do we mean by directly congruent? That those quadrilateral can fit onto one another directly without having to turn them over by just sliding them. So I'd like you to look at them. Look at the three of them there properly. Which ones are going to fit by just sliding them? Just look at them. So when you look at the first and the second, that is these quadrilateral, point it out. So this quadrilateral here and this one. So P1, Q1, R1, S1, and P2, S2. So these two, you don't need to overturn them for them to fit. You can just slide this one onto this and just adjust. By just adjusting, and it will fit. You don't need to turn it over for it to fit. So this is a very good example of direct congruency. So these and these, for them to fit onto each other, you just need to push this one to this side or this one, and then these points are going to fit P1 and P2 by just sliding it and just a slight turning. You don't need to turn it on the other side, turn it over for it to fit. Just sliding and just adjusting. So that is the first one. So the ones that are directly congruent, so we have P1, Q1, R1, S1, and P2, Q2, R2, and S2. Now what about the ones that are oppositely or indirectly congruent? So these are the ones that for them to fit, apart from sliding, you have to turn them over. Maybe on the other opposite, you have to turn them over for them to fit. And a very good example, when you look at these, look at image 2 and 3. Look at image 2 and 3. Image 2 and 3. So we have these and these. So for these image 2 and 3 to fit, when you just slide it along these, or you slide these to these, they will not fit unless you turn it over on the other side. You have to turn it over on the other side, not just sliding and adjusting for it to fit. So for them to fit, either you bring this second image to the third image, or the third image to the first image, and then you turn it. You have to turn it over. You rotate and turn it over for it to fit. So that is a good example. And then the other one, look at image 1 and 3. Also image 1 and 3. Also this one will not fit by just sliding and adjusting. You have to turn over one quadrilateral for it to fit onto the other. So these two. So we have image 2 and 3, and then image 1 and 3. So image 2 and 3. So we have image 2 and 3, P2, Q2, R2, S2, and P3, Q3, R3, and S3. And then image 1, P1, Q1, R1, S1, and the third one, P3, Q3, R3, and S3. So those are the ones that are oppositely congruent. The displacement S meters of a body moving along a straight line after t seconds is given S is equals to negative 2t cubed plus 3 over 2t squared plus 3t. Part A, find its initial acceleration, 3 marks. Part B, calculate 1, the time when the body was momentarily at rest. And then part B, there is B2, its displacement by the time it comes to rest momentarily. And then we have part C, calculate the maximum velocity attained. So those are the questions. Let's go to the first part. So in the question, you are given the displacement and you're supposed to find initial acceleration. Now, how do you find acceleration given displacement? So you have show you something here. So displacement, you differentiate displacement to get velocity. You differentiate velocity to get acceleration. So these downward movements, you always differentiate. Remember that. And any upward movement, maybe you're moving from acceleration to velocity or velocity to displacement, you're going to integrate. So in order to get acceleration, you need first, because you have displacement, you need to differentiate the first time you get velocity. So velocity, get velocity first, which will be ds over dt. So when you differentiate displacement with respect to t, this will give negative 6t squared and then plus 3t plus 3. That is velocity. Again, you differentiate velocity, that is dv. Now to get acceleration, acceleration is equals to differentiate velocity with respect to t, and this will give negative 12t plus 3. So now this is acceleration, negative 12t plus 3. So the question is asking, now you have the expression for acceleration, the initial acceleration. So at initial acceleration, time is equals to 0. So to get initial acceleration, you just take the expression, then substitute t with 0, 12t, this is 0, then plus 3. So acceleration will therefore be 3 meters per second squared. Part B, calculate the time when the body was momentarily at rest. Now, one thing you're supposed to understand is that when the body is momentarily at rest, velocity is equals to 0 at that instant. So at rest, when the body is at rest, velocity will be equivalent to 0. So what you need to do is simply to get the expression for velocity, which you have already obtained there, negative 6t squared plus 3t plus 3, and then equate it to 0. So simply take negative 6t squared plus 3t plus 3, equate it to 0. Velocity will be 0 when the particle is momentarily at rest. So when you look at these, this is forming a quadratic equation. You can divide all through by 3. When you divide all through by 3, you'll get, actually you divide all through by negative 3. Divide all through by negative 3. You'll get 2t squared minus t, then minus 1 is equals to 0. I'm dividing all through by negative 3. So this one is a quadratic equation. You can use any suitable method to solve these. If you use factorization, using factorization, you will get 2t t minus 1 plus 1 t minus 1 is equals to 0 when you solve this equation using factorization method. And this will give 2t plus 1 brackets t minus 1 is equals to 0. So you shall have two values of t. 2t plus 1 is equals to 0. And if this is the case, t is equals to negative a half. And then the other one is t minus 1 is equals to 0. So this one will give t as 1 second. So you have these two times. You're going to pick the one that is positive. So you shall go with this one because this is both time. You take the one that is positive. So t is equals to 1 second. That is when the particle was momentarily at rest. Then the other question, part 2, its displacement by the time it comes to rest momentarily. So already we have the time. We have obtained the time from the previous part, the time that the particle will come to rest, the body will come to rest. That is when t is equals to 1 second. So what we need to do to get the displacement, we are going to take the expression for displacement, which you already have. It is given there, which is negative 2t cubed plus 3 over 2 t squared plus 3t. And then we substitute t with 1 because that is the time when the particle or the body came to rest. That is t is equals to 1. So we simply substitute negative 2. This is a 1 cubed plus 3 over 2, 1 squared plus 3, 1. So when you work out that, you will get negative 2 plus 3 over 2 plus 3, which will give 2.5 meters. It is the distance. So that is the displacement by the time it comes to rest momentarily. Then the other question, the last one, calculate the maximum velocity attained. Calculate the maximum velocity attained. So one thing you should know is that at maximum velocity, that is maximum or minimum, it can be the maximum, minimum, acceleration at that point is equivalent to 0. So what you're going to do, you're going to take the expression for acceleration, which you already got. It is above there, negative 12 plus 3. And then at maximum velocity, a is equals to 0, just substitute. So negative 12t plus 3, that is acceleration, should be equivalent to 0 at maximum velocity. So this will give you the time at which there is maximum velocity. The time at maximum velocity. That is what you're going to get here. Time at maximum velocity. That is, this one is going to give t is equals to, when you solve this one, to give you a quarter second. So we have not answered the question. We need to get the maximum velocity. So what we got is the time at which it will attain maximum velocity. Now to get the maximum velocity, you simply take the expression for velocity, which you already have. We've done it before in the other part. The expression for velocity was negative 6 t squared plus 3t plus 3. So t is equals to 1 over 4. That is the time it attains maximum velocity. So you substitute that. And this one will give, negative 6 quarter squared plus 3 a quarter plus 3. So this one will give, when you work out this using a calculator, you will get 3.375 meters per second. That is how you're supposed to solve that question.